Well, hello there, everybody. Welcome to SkyTour LiveStream. It's a wonderful November 16th, 2021. I'm Mark D'Antonio, the weirdo who runs this joint. And with me tonight is, well, not so much of a weirdo, but a really good guy, Daryl Mason. Hi, Daryl. What's happening?
Hi, Mark. I'm good. How are you?
Good, man.
Don't believe me, folks. I'm pretty darn weird all by myself.
Yeah, but when he's in mixed company, he's not. That's what he's trying to tell you. So an interesting thing happened. Daryl and I were just talking about it a few moments ago. The ISS was actually put in danger by the Russians and a silly little weapon they devised. And I wonder if you guys in the chat know about it. The ISS is not in danger now, nor will it probably remain that way. I think it'll be fine. But boy, oh boy, the Russians have their own people up there. So what are they thinking, Trying to test out weaponry when ISS is overhead. It could be dangerous.
Oh, yeah. What's that? I've seen the name going around. Kessler syndrome?
Yeah. What about it?
Is it called the Kessler syndrome when you'll get like a catastrophic cascade of orbital debris?
Oh, okay. I'm not sure. Let's find out.
I think it's called Kessler syndrome.
Well, it'd be a very... Yeah, Donald Kessler came up with that. That's right. Density of objects in low Earth orbit. Basically, due to the space pollution is high enough that collisions between objects could cause a cascade in which they would generate lots and lots of space debris. Well, that's true. If you think about it, there was a satellite collision some years ago, and the satellite collision caused two satellites to disintegrate. Well, each of those little pieces flying in all different directions now contribute to the mess up there. And now that, and there's Carol. Thank you, Carol, and hi. To the debris field up there, and that makes it more likely that collisions will occur, and then it's a cascading event that occurs. That's really bad, and that's kind of what Daryl's referring to, I think.
Yeah, they supposedly, a worst case scenario, we could the debris could get so bad we could no longer work in space.
Yeah, unless we design ways to clean it up, which actually there are. There are ways designed to clean it up, and they just haven't gotten to them yet. Because, you see, until it's actually facing us, you see, humans don't develop anything ahead of time. They react. I want to say hi to Cypher, too. I want to say hi to Vera Lucia Campos from Brasilia. Welcome. And I want to also say hi to Carol, who was the first one here. Well done, Carol. And DoW is here. We have Cypher 2 Productions is here. Good to see you again, as always. And Daisy and Zoe Amethyst are here. And we have, who else now?
Don't forget Lane. Lane is with...
Is Lane with them tonight?
Yeah.
All right, Lane, how are you? Good to see you. Well, not see you, but good to have you with us.
And Marianne is here.
No way, she's not here. There's no Marianne here. C&D Boy is here. Hi, Marianne. How are you? I see Marianne Robb is here. Yeah. Good to see you, Marianne. Hi, Rascally. Rascally Rabbit is here. I tell you, he's a rascally rabbit. Yeah, it's good to see you. So, and we're off and running. I don't know how long the clouds are going to hold out. We do have some high clouds that are coming toward us. But we also have a waxing gibbous moon, meaning it's a 3/4 full. On its way up. It's going to be very bright. So tonight I thought we would look at clusters. And so this is one right here that we have. And let's go. The green is an artifact of the filter coupled with the moonlight bright. So we want to kind of get rid of that as soon as possible. So what we're going to do is we're going to do we're looking at Measure 2, which is a globular cluster. And I'm going to test the focus here and go and do a 10-second shot of this. And we're going to go stack it, live stack it. By the way, we're getting rave reviews for our latest imagery because the images are coming out so beautiful. And we're just so happy that this system is now working so much better.
Isabella's here, too.
Isabella Melamed and Cindy Murphy is here. Joel Sweatman is here. Hi, Joel. Hey, Cindy and Isabella. How are you guys doing? Yeah, they are here. Everybody's here. The gang's all here. Yeah. Okay, what are we doing? I must have missed something here. Oh, yes, I did. I have my gain down to 1. I have to bring that up higher. I'm going to put the gain at 250 tonight because I don't think we need to go to the full gain. Gain is like the ISO or the sensitivity, but tonight that's not going to help us too much because the moonlight is so bright. And I think that's going to be one of the problems. All right, so what we're going to do is we're going to start this over. We'll do 10 seconds, and we're going to go to live stack, clear it, and let's start again. Start again. All right, so it has been reset. All right, and let's see what happens. The green progress bar on the bottom. Look, see that? The green progress bar is filling up, and I need to just adjust our settings here, which we can do like this, and then like this. Yeah, and now it's more like we need to see it. And what we can do is to actually, because they're clusters now, we can actually slide this yellow curve, as you can see, this yellow curve right here. This is the data. These RGB curves are the data. Right? That means red, green, and blue. And what we're going to do is we're going to take the data, this line intersecting the data, we're going to move it a little bit out, so it's going to have less data hitting the center. And the reason that's a good thing on nights like tonight is because the moon is so bright, it's going to allow us to do this, darken up the sky just a little bit. Okay? And then we see our beautiful cluster there. And then what we can do is now take this left-hand one, which is called the black level, and we're going to move that to the right a little bit. And that's going to take our background sky, which is kind of grayish, and darken us up a little bit. Now we can zoom in and see how well it looks. Let's go right to 100% and see if our focus is on the money here. Yeah, we're pretty close. Look at that. You can resolve this to individual stars. Isn't that beautiful? That's not bad. I really think that looks good. Yep.
The clusters don't get enough credit.
Right. Hey, Hunter, how are you? Awesome. My son was just down here for a second. Hunter, whose middle name is Orion, incidentally. My other son, Gabriel, his middle name is Galileo.
Old friend of mine's son, his middle name is Orion.
No, sir.
Avery Orion is his
Oh,
name.
that's a great name. Well, rascally, unfortunately, the moon is only getting brighter until it gets to full. But then after that, when it's on the back side of its cycle, then we're going to have darkness in the early hours. It'll be really nice. And this is a globular cluster, and clusters like this have tens of thousands of stars. And the stars are generally what we call metal poor. If you remember your periodic table of the elements, you notice that the first, number 1 in the periodic table is hydrogen. Number 2 is helium. Okay? Then you have lithium, beryllium, and carbon. Okay? The thing is, hydrogen's the most abundant element in the universe. Helium's the next most abundant. It turns out that oxygen is the next most abundant, followed by carbon in order of abundance. But when we look at a globular cluster like this, what we find is that when we look at these stars actually have very few elements beyond helium. They basically are very, very unpopulated in things like magnesium and calcium and xenon and any of the others that we normally see. Our sun has tons of lines in its spectrum showing us these elements as they're absorbing a little energy, and it takes a little sliver out of the spectrum. We can see all those little slivers, and we identify these lines called absorption lines, And these things will cause us to be able to detect what's in the star in terms of its composition. Well, these stars, in these guys right here, are very, very low in anything other than hydrogen and helium. And you know what? Astronomers like to confuse you. You know, we call stars like this low metallicity. It has low metal stars, poor in metals. And you say, but wait, you know, let's be honest here. Krypton is a gas. It's not a argon's a gas. Oxygen's a gas. Why are you calling it a metal? It's certainly not a metal. And you'd be correct by the strict definition. But anything other than hydrogen and helium in astronomy is regarded as a metal. Because we use the ratio of hydrogen to other things. Yeah, see, look at SkyTour LiveStream. You know, make sure you subscribe if you haven't, okay? Because this is a wonderful place to be. Okay, go away. Go on. Thank you. There you go. Close up. Okay. Yeah. So metals are actually poor in these stars. So these are old stars. It also means that since these stars are old and don't have a lot of materials other than hydrogen and helium, it means that tens of thousands of stars like this here probably also don't have planets, because there's not a lot of dust in these clusters that could provide material to build planets. So these clusters aren't generally thought of as being planet-bearing clusters, but they are beautiful, though, aren't they? Yeah. Jumpin' Jack Flash is a gas, Carol Carl says. That's right. Hey, Rock, how you doing? Tim F., what's going on, brother? Good to see you. You know? Yep. Rascally's talking about the lunar eclipse coming up before dawn.
Uh-huh.
Yeah. I don't know if we're going to get to see it, but I'm going to try. But I don't know if anyone's going to watch it. You know?
Oh, I'll be looking at it. I probably won't make it through the whole thing, but it actually the eclipse will get interesting. 11 o'clock Mountain Time.
Yeah.
Thursday night.
Yeah.
And then go from there. And the farther east you are, of course, the later it'll be.
Mm-hmm.
Be 10 o'clock for those in California, and my sister in Hawaii, they're going to have primetime seats for it over there.
Yeah.
8 o'clock at night, I think.
Yeah. We're not going to have primetime seats. We're going to need to be we're gonna basically be non-prime time, but that's okay. We can still try to see it, right? So maybe we'll do that.
Sure. It'll be interesting. 1 o'clock your time, I guess.
Yeah. So I think
it's a deep partial eclipse, folks. It's not quite a total eclipse. There'll just be one little sliver of the moon that you may see a little more light on. The umbral, the deeper total shadow, won't quite make it to the one edge of it, but it should still look cool.
Yeah, I bet it will.
And as people have been saying, it's a very long eclipse too.
Yes. Yes, indeed.
And as I mentioned in chat, the Leonid meteor shower peaks tomorrow night into the morning of the 18th. It's generally best from midnight till dawn.
Right.
But
the Leonids are gorgeous.
I'm sorry?
The Leonids are gorgeous. So they have these beautiful green trains behind them usually, and I've seen some tremendous... I stayed up and watched them like every year if I can, and they have these beautiful, beautiful trains in the upper atmosphere that you can see left behind. Very, very nice.
Oh, 1 year, 98 or 99, I think, they were like Roman candles going off. Every color in the rainbow, too. They were just screwed.
Mm-hmm.
It was beautiful. They were all big, bright, and very colorful.
Yep.
And a couple of years after that was when the big storm happened. There were thousands of meteors an hour visible. It was the second coolest thing I've ever seen in the sky.
Yeah. What was the first coolest for you? Omega Centauri?
The total eclipse in 2017.
Okay. To me,
Got to see that.
the best thing we saw was the 2019 lunar eclipse, in which we caught the meteor hitting the moon.
Uh-huh.
Yeah, I mean, you can't get much better than that, you know? Yeah,
Well, the 2017 solar eclipse, that was the big total one. And
yeah.
I drove up north of Scottsbluff, Nebraska from here in Colorado to see it. And it was everything I'd ever hoped to see in a total eclipse.
Wow.
Only one I've ever seen. It was tremendous.
Did you see the interference patterns?
I did not. We were
Okay.
watching for all sorts of stuff like that, and it came so fast. We had less than 2.5 minutes totality
Okay.
also. So I was riveted on the sun the whole time.
I believe you. Did you get to see prominences at totality? I bet you did.
I did, yes.
Little red spots around the edge of the sun.
Yep. There were 2 or 3 of them, as I recall.
Okay.
It was tremendous, and the corona was really great.
Very nice.
It was beautiful. So that has to be number 1 for me. And before that, the Leonids that year were the best, and
Yeah.
but now the Leonids take number 2.
Wow. Okay.
Anyway, Leonids are overnight tomorrow night, but the nearly full moon will be a factor. It'll wash out fainter meteors.
It probably will. And we won't be able to really see them with our telescope, even though we have a 2 degree by 1.5 degree field. Unless one goes right through the field, we get lucky. But it's very early in the morning when we're going to have to look at those. So, I'm not sure I will.
Well, I'll go out and look, but I doubt I'll make it all the way through till dawn. As I said, they're usually best between midnight and dawn.
Yeah. If I wasn't streaming tonight, I might actually stay up or go to bed and then get up at like 3 and start streaming. But no one's awake. None of you are awake,
There's some night owls here, aren't there?
Yeah, I'm sure there are. So I like this cluster. I kind of corrected the colors a little bit. There's a little too much red and yellow in there, but that's okay. You get the idea. That looks pretty, though. And by the way, we're at 100% of the size of the sensor right now. Here is what we've been looking at normally when we've been looking at these, okay? We've been looking at this size right here. So we've been able to, by going out there and fixing this telescope's focus and collimation actually issues, we've got a tremendously better view. And our Rosette Nebula from the other night was just so stunning. I had to stare at it over and over. So much detail visible inside this thing, and it was just gorgeous. Okay, now I'm gonna just save this exactly as seen. So if anyone wants to play with this, that's good. Alright. Hey there, Fantasy. Fantasy's here. Fantasy Ecstasy. Thanks, Cypher2, for putting that up. I was just thinking that. You reading my mind. Very good. Thank you. Okay. I've stopped stacking right now, and what I'm going to do is we're going to go find another object to check out. I want to look at some of the open clusters. And some of the other things that are out there. So let's do that. Let's back out of this. If you look up here, you can see the telescope is pointing that way. That's west. Okay, that's east. North is toward the back wall, and south is toward us, So that's where we're looking. Alright. We're going to probably spend more time up north. Yeah. Yes, sir. And there's the Andromeda Galaxy. Should I go to the Andromeda Galaxy just so people can see the Andromeda Galaxy tonight?
You can try.
Yeah, it's a little bit bright, but you know what? Why not? Shall we try it? Yes, we shall. Okay. If you look over there, you see the telescope's going to start moving. There it goes. And I'm going to clear the light. Well, clear this all because we've done this already. Clear this stack. And get out of this. And now what we'll do is come back and go from 10 seconds to 1 second again. And that's the star that we're going to use as a finder. I'm not sure which star it is, but it's going to be brought into the middle, centered up. And okay, so it's that star right below the Andromeda Galaxy. Okay. So the star we used was Mirage. And now we're going to come back and see the Andromeda Galaxy right here. So let me get the thing set up. Do this. Alright. And it's kind of near the moon, which is kind of interesting. So let's check out how it looks. It might be hard to see a lot of it, but we'll find out. Alright, well there it is. Okay, we're going to go south a little bit so we fill the view. Hi, Katie Q. Colorado was absolutely wonderful. You know, I spoke for the Colorado MUFON. Katie Grabowski, who is the director of the of MUFON, the state director of MUFON in Colorado, is a real mover and shaker, and she's just amazing. She actually gave a wonderful talk at the Phoenix Boot Camp, and then she proceeded to say that she wanted to have me look at coming to Colorado, and she took to canceling the trip. I think Marianne actually canceled the flight out on Friday, and Katie booked the flight for Friday and had me flying out on Sunday to come back to Connecticut. The Colorado group is a very nice group, you know. And I talked about Marianne's talk that she did in the Colorado MUFON because what Marianne talked about was as a police officer, she talked about interviewing and what you look for in when you interview potential perpetrators, you know. And it was kind of neat. I was able to use some of that in my own work in the past because of her. She made me aware of it. And I knew about some of it in the past, but, you know, she was really good at doing that. So she and, well, it was Dave Rich last year, but Dave Rich was sick this year and couldn't come out. So if Dave, you're listening, shame on you. But it was okay because she was very good about showing people how to do interviewing and body language things that, you know, that she talked about. For instance, when you ask someone a question about a potential crime and they start off by saying, well, to be honest, okay, she just nodded yes, I could sense it. Okay, hey, Wayne Pinkham, good to see you. You know, to be honest, that's called a preparatory phrase, and those are usually a setup for the lie. To tell you the truth, well, no, lie to me, right? Yeah, so, so that's really kind of interesting. Reminds me of a show that was on called Lie to Me, in fact. Remember? Do you remember Lie to Me? Daryl, did you ever see that?
Doesn't ring a bell.
Oh my gosh, that's a great show. It was this really abrasive character who was he was actually a human lie detector, and he knew all about body language and stuff. And they actually based the show on very real techniques, so it actually was kind of interesting to watch. Really kind of cool. All right, this will be 20 seconds on the Andromeda Galaxy. The colors probably won't be right, but maybe they will. It depends because the settings remain the same. So it might be relatively close. Let's find out. but I can correct the colors a little bit. The green bar is almost done. You can see right there. And what do we got? Wow, okay. Pretty bright. We got the moon right nearby. So what we can do is go into our stack here, and we can change where the black level is. And that will allow us to darken this up and pull out some of the other data, some of the details. It's hard when the moon's out anyway, but this is sort of a test to see just how much of this we can pull out. You know. All right, let's see. Let's bring this up a little. All right, and now come back to this. Let's go ahead and darken it way the heck up. Yeah, see, to get it as dark as we normally see it, as you can see, we lose detail, right? We lose the extremities. But when the moon's out, there's literally only so much you can do. But that's why I look at clusters when the moon's out. Yeah, Marianne, I was actually listening. Oh, I don't try to lie to you because you'll just tase me. You know, at least that's what she says. She's never done it, so actually I don't think she knows how to use a taser, to be honest. Yeah, Isabella remembers the show. Yeah. Yeah, really good show. Yeah. Okay, so let's go and let's see how this looks when we get out of this, and there we go. The moon is just, KDQ. The moon is so close to us that we can't really see too much detail here. The other night, if you want to see detail, wow. Rockstar asks, what's the nearest exoplanet to us? Well, that's an excellent question, Rock, and I'm going to answer that. The nearest star system to us is the Alpha Centauri star system. And the nearest star within that, because it's a triple star system, there's Proxima capital A, Alpha Centauri capital A, Alpha Centauri capital B, and then Alpha Centauri capital C. And the C, is a red dwarf star. Okay, the A and B are stars kind of like the sun. And the capital C star, I use capital because that's how it's denoted with a capital letter. And I think that the triple star systems generally aren't as stable as they could be, but in this case, A and B orbit each other very close, and C is going around way on the outside, and that's kind of cool. So that makes it more stable. Okay, so logically, to the C star, this red dwarf star, those two stars in the middle are really close to each other and are like a logical gravitational well for this C star. So it doesn't have any need to be or will be ejected from the group at any time soon. So, but that C star actually has two planets around it, Proxima B and Proxima C, and that's little b. Okay, so basically, you can say capital C little b, is Proxima B, right? And capital C little c. Okay, see how we're doing this? The small letters are the planets, the big letters are the stars. So big C, little c is Proxima C, the little planet. Hello, Volkish Fräulein, how are you? So it is kind of neat. So we can't see Alpha Centauri from here. We're just literally a few degrees away from being able to see it. But I am putting the telescope on a lifting column out there. So basically the column's going to lift the telescope up another nearly 20 inches. So it'll be above the edge of the wall. So to actually be able to see a lot more. So once we lift it, the telescope will move to all these different locations. And then what we'll do is, when we go to close the roof, we'll be lowering that column back down, and then the roof will close after the telescope is shut off. So there's no way in the world that we're going to be able to shut the roof while that's open, because it'll just destroy everything. Let's see. Can you show us from where you are at? Yeah, okay, let me do that. I think I know what your question is. All right, so if we back out of this, okay, and we come back, okay, we actually have the horizon and the ground, right? Well, let's get rid of the ground. So we just get rid of the ground for now, okay? And now, all right, what we're going to do is we're going to do a search, and we'll find Alpha Centauri, all right? And then I'll show you.
Well, it's going to be over in the morning sky this time of year.
Yeah, it's going to be way down, but, you know, we should see it. I'm trying to get back so I can respell it. It's like it's 1 second delay.
Southwest of Scorpius.
Mm-hmm. All right. So now, this is Rigel Kentaurus, which is also known as Alpha Centauri. And here it is. And we zoom, 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 zoom. All right. There it is. Rigel Kent. All right. And so this star is actually, I released it from its bonds, and now it's doing that. All right. But this star is the nearest star to us, and it's actually a triple star. All right. It's a triple star, and that's the star that has Proxima Centauri. There's two of the stars in the middle. Like I said, they're stars like the sun, relatively. One's sort of like the sun. It's a G-type star. And the other one's, I think, a later type. I think it's a K. I'm not sure. I think it's a K. And from the OBAFGKM thing, classification. And then there's the Proxima, which is the red dwarf star. All right. So that's what we got right there. So that's where it is. And if we come back a little bit, you know, if we were to look at things we can see, all right, when the Milky Way is up, okay, we can actually see down to, let's find out here. Just about, I think the moth wing is about as far as we can get. I'm not sure. Yeah, the butterfly cluster, mothwing, that's about the where we can see to. So we can't see below that. So we're actually just out of tantalizingly just out of reach for that, and that's sad. But it's okay.
I never knew that Alpha Centauri was called Ptolemy or Bungula.
I know.
Bungula, that's a funny name.
Yeah. Well, think about it. Look at the names of the spelling too. Rigel Kentaurus. Okay. Ptolemy, or Rigel, like Orion's Rigel Kentaurus. Mm-hmm. And then Bungula. I've actually not heard of that myself.
Me neither.
I think those are probably catalog names from obscure catalogs too. So I don't think that Stellarium created these out of nowhere.
I'm gonna look that one up.
All right. All right, so we're back now. All right. And we're going to bring our ground back. All right. So if we don't want the moonlight to bother us, I can actually just, you know, turn off the atmosphere now as well. But we'll leave it on. You know, and then we'll just move around. So now we're going to head up. No night is complete without looking at this guy anyway. We're not going to be able to do too much with nebulae tonight. But we can certainly do some stuff with the double cluster, and we'll do that in just a moment. Okay, so we're going to come over here. Okay.
Ptolemy is actually the name of Alpha Centauri B.
Okay.
And I haven't found Bungula yet.
I won't be saving this because we have so many that are better. So we're just going to get out of this, come back, and we're going to go to 1 second, exposure, right here. I cannot wait for my Starlink to come in out there because we're going to have so much better viewing and be more real time. Such a delay right now. Okay, let's go back to, well, what's this do? Oh, I see what's happening. Yeah, I had this is weird. Sometimes it resets all the placements. I don't know why it does that. I don't like it. It's weird. Maybe it doesn't like the jazz or the blues music, rather. I don't know. That's a joke. Alright, let's just put this back where it belongs. I only use a certain segment of this program here. Okay, almost.
During the 19th century, the northern amateur popularist Elijah H. Burritt used the now obscure name Bungula, possibly coined from beta and the Latin ungula or hoof.
Ah. Well, Centaurus is the centaur.
Yeah.
All right. Very cool. All right. So here we go. Let's go and just move a little bit south. Let's try this. Okay, now we're going to go and head over to our selected object, the double cluster. Off we go. There we go. Telescope's on its way. See, I have the telescope set, by the way, guys, to 1 second exposures. I can change that. I can change it to 500 milliseconds. I'll do that. I'll just show you. So 500 milliseconds or half a second, and then it'll look a lot more, look a lot quicker, you know. All right. There we go. See how much faster it's all moving? Yeah. And then we have our beautiful double cluster. Hello. Hi, honey. How are you? I haven't seen you for a while. Very nice. Very nice. Very, very nice. Yeah, and now what we're going to do is head on over to our exposure. I will make this we'll make this 10 seconds, and then we'll take out the high processing level and just go into live stacking. We're going to clear this, and then we'll see our beautiful double cluster. And there we go. So now what we have to do is just give it a little bit of love by processing a little bit more. There we go. Oh yes, that's beautiful. Drop down some of the blue a little bit. Oh yeah, look at that. That's pretty. Too much. Let me just do this. Okay. Try this. This is probably going to go blue on me. So do this. And drop the red. There. Oh, almost. I was almost there.
talked the other night,
Yeah.
the left-hand cluster appears to have a lot more red stars in it.
Yeah. We did, and I think that that's could be due to the fact that the cluster has some interlopers that are in the foreground, because the clusters are all the same types of stars. And the reason that is, guys, is because when the actual, I think Daryl's probably answering your question, Marianne. When the clusters are born,
I am.
I figured.
Sorry.
That's fine. When you look at the clusters, they're all born from the same material at the same time. So the stars are all relatively the same type, and so they're hot and they're young. And when you see red stars, the red stars are indications of either red dwarf stars, which are the little percolators, I call them, in the universe. They go trillions of years, or they're red giants from the end phase of other stars' lives. But these are young stars in these clusters. We don't expect them to be the end stars, the end state stars. And we don't expect them to be red dwarfs either, because they would not be formed in the nature of the cluster, because the cluster is all young stars. Hi, David Schmidt. So, what was Marianne asking? She said Orion was so. Oh yeah, she said Orion was so brilliant in the sky. No, I'm sorry. Okay, she said Orion was brilliant in the sky. Any way to look at it, if you could see it at that time. Oh yeah. Well, yeah. Did you answer her?
I did.
Okay. Basically, Orion is up fully by this 2 hours from now in this observatory. You'd see Orion, because it's 8 o'clock out there. We're now at 2 hours time frame difference. So, all right. So that's cool. This is beautiful. Let's do this. Let's get this the heck out of the way, and let's maximize this, shall we? Yeah, there we go. And let's make this go away. Ah, look at that. Wow. Those are beautiful stars.
Yep.
Yeah. You can see these red stars here. Again, red stars actually, look at, there's two tiny ones there. And there's red stars everywhere. Let's actually, I want to zoom in on this because I want to show you this. Just to give you an idea. Okay, we'll go to 75%. Okay, because that'll still keep everything in here. Okay, oh, looks like we got to focus. Temperature is changing. So we're going to refocus. All right.
Well, you want to see temperatures changing.
Yeah.
It's been 70 or so here lately.
Yeah.
And cold front is coming in as we speak. And
Mm-hmm.
it'll be much colder tomorrow. And they're saying first night in the teens tomorrow night.
Okay. We're going to come back to this in a minute. We're just going to go focus again. So we're going to go here. We're going to go down to 1 second. Okay, 1 second. Exposure time. And now let's bring up the focus. And I have a few more that I came up with. Let's try this one. This one worked the other night. We can go to a variety of them, but let's watch what this does. Watch the star images. Okay. Let's try this one. I think that was the one I had.
That looked a little better.
Yeah. So we're gonna see it. We went from 48, 645 down. So let's see if going down makes it even better. Let's increase the size here and take us out of this. Actually, just take us out of this mode right now. Come on, 1 second delay. Stop it. That's better. Okay, now let's zoom in. We'll go to 125%. And we'll see stars. There we go. So now what we're going to do is see if we can change our focus and get it better. It's getting better. And then you'll get to a point where it's going to go the other way. And as you can see, that looks a little better, doesn't it? Right? So let's go. Let's see, that's 48, 358. We'll go 48, 358. We'll add that in as a anchor point. And that's what we're going to be set at. All right. So now we can minimize this, back out, and go back to taking pictures again. And I suspect we'll see that the cluster's going to look a lot nicer. But we'll find out, won't we? So let's do 12 seconds. Okay, there we go. And we'll live stack it now. James Dugan, how are you? G'day, James. Good to see you. Okay. Now, look at that. Tell me that doesn't look better, man. That looks really good. All right, so let's get out of this. All right, let it do its thing. And let's zoom in a little bit. Make sure that this is looking like a nice cluster that I suspect it should. We'll go to 100%, see what we got. Okay, now we're talking. That's looking good. Okay. We're going to just back out a bit so we can see this as a whole. Go to 40%. There we go. We'll move this over. I like this song, so I'm going to put it up a little louder. Sorry. I'm going to make some adjustments while the music's playing. That looks nice.
It does.
Let's reduce the black level a little bit. This is going to look nice. Look at that. Ah, ha, ha. Wow. Wow. Now that is pretty. Let's maximize that. Look at that. Isn't that pretty?
It is.
Uh-oh.
Double cluster is a nice binocular object, too.
It is indeed. And that's the nice thing about the double cluster is that any pair of binoculars will show it really well. Yes, sir. I like this. Look at that. Daisy and Zoe Amethyst ask, what is the title of the music? That last song was... I don't remember. Let's go back. Desert Caravan. Okay.
I thought so.
Yeah. And
you played that when we looked at the elephant's trunk in the caravan a week or two
I did
ago.
indeed. It was like an excellent theme music for that. Look at this. Isn't this beautiful? I don't know. I'm telling you, I just seeing clusters on a moonlit night just never gets old. It's beautiful. Let's just see if we can drop down. Make it even better here. Might be too much. we go. That's pretty, but not what we want. Let's start back again. It'll put too much red in, that will drop it down. Yeah, that looks pretty good. Maybe go up a little bit. Hey there, Lady Love FTP. How are you? Well, I'm glad you came. We love to have people here, new people. Nice to see you. Let's actually drag that black level over a little. Oh yeah. Now talk about a beautiful sky. Look at this. Look at this guy. Yes, sir. Hey, Genghis.
You know, I'm seeing dark lines in that image, like I do sometimes. I'm wondering if somehow that's not an artifact of the processing.
Where are the dark lines?
Oh, scattered all over the image.
I don't think it is, because when I do what's called a flat field, they're not there. David Schmidt writes, Mark, astronomical question for you. Why are celestial toes tapping? I don't know, Dave. I don't know where you're going with that. I might be missing I might be missing the hint there. So David will fill me in, I'm sure. Lady Love is saying hi to you.
Yes, I said hello to her.
Okay, that's why she said hi. All right.
David Schmidt, I occasionally see dark lines in these images. Some of them look real, some of them makes you wonder if what I'm seeing is real or not.
Like this?
I see one over on the lower half of the right-hand side. It's more of like a void than a line. Farther to the right there, Mark. It's going up and down. Right there.
Yeah, no, if there's no stars there, then it could be perceived. Your brain will make it straight when it may not be.
Yeah.
And
I see several others in the field.
Mm-hmm. I'm sure you do. Your brain will make chaos into order. That's pareidolia, you know. And I think that's what you're suffering from with this. But look at this. Look at that. I mean, that's beautiful. It's got color.
There's that other image, one image we see sometimes. I forget which one offhand, but I always say it looks like spider legs.
Oh, yeah. You were talking about near the Seahorse Nebula.
Yeah.
Yeah. Or maybe near the Elephant's Trunk, one of those others. Yeah. Yeah, see? Oh, look at Heidi Gadd's here. Hey, what's up? Nice to see you, Heidi. Thanks for dropping by. Heidi's a really cool lady. She lives out in the Phoenix area. She was helping to put together the UFO Congress. And, you know, just working her butt off to get that going and for what she was doing. And yeah, she did a great job. So Heidi deserves some love, guys. Show her some love. Yeah. Creamers is here. Hey, Creamers. And Creamers, I think you're right. The voids are actually there. But what we don't see because the moon is out is we might be seeing some dark nebula here. I know that this is in the Milky Way location. And so we might be seeing dark nebula in here that we can't really see until the moon goes away. And we do a deep photo. Because we actually never have done a deep photo of this. I mean, like literally 1 minute long or 30 seconds per exposure and then stack them. You know? But this is probably how it works. Yeah. Okay. Oh, so what do you follow with when you've got this beautiful cluster? You know, I don't know. You have to figure it out. Let me just try and add a little extra dimension to this. Ooh. That might be just a bit much, but at least you can see it like you might see it in a good telescope. Yeah. All right, so let's take that back a little bit. Work it back. Work it,
Yes.
work it.
Excuse me for a moment, please.
Absolutely.
Right back.
We'll be right here. Okay, so we're gonna pause this. We'll save this one, so if anyone wants to take this and have some fun with it, they can. And we save the stack, which is what you see across the top there. That's a stack, and that's why I moved this earlier, just so you could read what's up there. And then we're gonna save the image just like you see it, and then you can have a really cool picture to just stick on your desktop or whatever. So that way, you don't have to do any work to get a beautiful picture. We just do it for you. And it's all done dynamically. I think that's really cool. Yeah. Okay, so let's go into the live stack. And let's get rid of this stack. Come back here. And go down to 1 second again. And there we are. Now we'll go into our hyper mode where we actually show it quite nicely. And we drop out of this full screen mode. And so we see everything going on. Not bad. Pretty cool. Yes, sir. Okay. And now, that looked cool, didn't it? When you just streak some stars, it looked kind of neat. Alright. Now we're going to head to a few more open clusters tonight. Okay, this is the Dragonfly cluster. It's right nearby. So we're going to see the telescope move just a little bit. It's going to go down to a star. Where it's going right now, it's going to go to a star, bring that star into the center. And from there, it's going to plow on over to this cluster. The green color is due to the filter we use, plus the fact that there's bright moonlight out there. The complementary color that the filter induces on the sky is green. But don't worry, we fixed that. So are you guys having a good time? Dagger, I would encourage you to look up the lunar eclipse to find the exact time. Okay? Because I don't know it, the exact time offhand. It varies for where you are. Daryl's back.
I'm back.
Wow.
Did David Schmidt ever answer a little cosmic riddle he posed?
I don't know. I don't think he did. If he did, I didn't see it. David, you better not have done a hit and run. Yeah, he did. He said, gotta go. Be back later. Why, you? Yeah, he may have answered it. Gotta look up in the chat to see.
Okay.
So, but all right, this is the Dragonfly cluster. I don't know why such clusters are called the Dragonfly clusters. Or Dragonfly cluster. But if you notice, it's just such a beautiful cluster. And also notice that when we move the telescope, the colors of the stars are more apparent. Okay, you see that beautiful orange star right there? Watch when we drag it now. Okay, you can actually see that orange really nicely. Okay. We're going to do 10 seconds on the Dragonfly cluster now.
I think he did answer, Mark.
Okay, what did he say?
He said, Mark, astronomical question for you. Why are celestial toes tapping? Question mark.
Right.
Then he said, it's the music.
Oh, okay. That was a bouncy tune right there. That's true.
Yeah. Okay. Dagger spell. Give me just a moment, and I'll get those numbers for you.
Thank you, Daryl.
Yeah.
I'm doing like 6 things at once here.
Uh-huh.
Okay, here we go. Dragonfly cluster. It's right there, and we're gonna now process a little bit of it. See what we get. Oh, look at that. Really pretty. You'll notice that you see this noise in here. There's this sort of modeling. That modeling goes away in time. We'll stick out here for a while, so let's maximize. And we're gonna take this guy down if I can. I'm gonna bring this entire screen lower. I know we can do it. I know we can grab it, but the delay is just maddening. There we go. Let's see if I grabbed it. Yeah, okay, good. So we see a little bit more of it. And when I go to this mode, we'll see all of it. There we go. Hey, don't forget, guys. Subscribe. If you haven't already, just subscribe. You know that this is what a nice place to go. This is a place to go on those wonderful nights when you just want to see stars. This is where you come. There's a dragonfly cluster. Let's play with that just a little bit, shall we? I used to play with dragonflies when I was a kid. I thought they were the most miraculous flyers. And I always wanted to be a dragonfly. Wow. That's pretty. Check it out. The dragonfly clusters are a very rich cluster, and we have this beautiful red star down here. And let's find out what that star is, because that's a fairly bright star.
I'm posting the times in chat.
Good. Thank you.
Then I'll post a link to where I'm
Okay.
getting it from. And as people have been saying, they say this is the longest lunar eclipse in 600 years.
Wow.
Yes, Daggers. Okay, here's a link. You can look at it at your own convenience. It's all over on the web.
And this... Oh, look, we had a faint satellite go through. This is V465 Cass in Cassiopeia. It's an orange star. Actually, I want to see what the... Keep in mind, the telescope's flipped upside down, so the images are flipped upside down. They're flopped, so the top is the bottom is the top. Okay, so let's say we're here. Okay. And that's where we want to be aligned. The telescope is really close, and so I'm just moving the planetarium to where it needs to be. Okay. And V465 Cass is a very, very red star, as you notice. It's an M4. So in the OBAF, going from hottest and bluest to coolest and reddest, OBAF GKM. And then further down the list from M0 to 1, 2, 3, 4. But then it's a 2, which means it's a star that's a giant. Okay. Okay, so that's what that star is.
Okay, what did I miss?
I don't know. What'd you miss?
I don't know. I've been posting stuff in chat.
What'd you miss in chat?
Will you be able to see it here in Rio? The early parts, I assume, if I remember correctly, Rio is actually pretty far east. Uh, you may miss the later parts of the eclipse.
I do believe that's true.
Yeah, if you look at those times, they're posted in the U.S. Eastern Time Zone, but they also give them listed in Universal Time. If you know how to convert Universal Time to your time, Universal Time is the same as Greenwich Time or Zulu
Mm-hmm.
Time. Uh, you may be a couple hours ahead of even Eastern Time in the U.S.
Mm-hmm.
But I bet you'll see at least. You may have to stay up really late, but you should be able to see at least the first part of the eclipse.
Hey there, weird guy. And PG, I don't know how I missed you. How you doing, Petita? Petita has joined us. And I have to say, I did my talk in Colorado, and you know who was there? Anahata77 in chat. Bonnie.
Oh, really?
Bonnie showed up. It was very nice to see her.
I felt guilty ever since I heard you were coming because I didn't go.
That's okay. You know, you had stuff going on. You weren't able to go. That's okay.
Yeah.
I don't hold
I
it
looked
against
it
you.
up and saw where you were.
I know it wasn't far from you.
Yeah. Well, it was an hour or so away.
Oh,
I think.
okay. Hi, Charlotte.
Gee, they were charging admission at the door too.
Yeah, they were. Hey there, Charlotte. I said hi, but I don't know if you heard me. Well, Charlotte, welcome to SkyTour LiveStream. This is our beautiful live observatory. It's a live deep sky observatory. Everything you see is live. All the images, the music. No, it's not live. I don't have an orchestra here. But this is our main screen that we look at. Okay, this here is the computer view into the telescope. That'll be active now and then. That is the telescope in the building. Up top here, you actually see this is the telescope control system right here. Okay, and then all the way over on the other side, this is, of course, is the main view all around us here. And then on the other side here further, pull that out. Okay, that is our camera control system. Okay, we have the exposure here. That's the most important thing. Okay, right there. And then down here we have something called the gain. The gain is like the ISO or the sensitivity of the camera, and we're at a lower gain than we normally use because the moon is out and bright. This is this yellow line represents the data that we're getting from the sensor. This red, green, and blue lines all together, this is the data coming in from the sensor, and the yellow line shows us a cross section through it. This is how much from here down is what we're seeing right now. If we actually were to come over here and increase that, all right, then here's what happens. As you move that line over, it gets bigger and bigger, and you'll watch the screen get brighter and brighter. Okay, so when the moon's out, we don't want to do that so much, so we just leave that off. We don't play with that. Okay, especially when the moon's out. Okay, so that's how this all works. And so we're all over the place here. I zoom around, I point to things in the sky, like this beautiful cluster right there, you know. And then we also have, if you look at, you'll see it just, well, of course, then we have our SkyTour LiveStream. We also have this beautiful planetarium that we bring up. This planetarium is actually a planetarium that's linked to the telescope and controls the telescope. Currently, we're here. We're watching this cluster. This cluster is called the Dragonfly cluster. As we zoom in, okay, we can see that we're actually, we're looking at this beautiful cluster. The telescope indicator shows us a plus there, that plus sign. Okay, so that's pretty much how we get around in the sky, right? So as being that you're new, I thought I'd run through that for you so you can see what we do. And so that said, oh, and when we take pictures, by the way, Charlotte, you see this here, this cluster, we've been stacking this image. We've been taking multiple images and stacking them on top of each other, and that removes noise and other things. And down here, right there, you see that live stack. Okay, this is the stack right here that we're doing. That just means, we're stacking lots of pictures. The thing that's important, though, is to just look at the number of images we've stacked. See that right there? 54 so far. 54. Okay, up 55. And that's enough for this one. So that means that we've averaged out a lot of the noise that you would get on a bright night like this. And it makes it look a lot nicer. And as you can see, it's really pretty. All right, so we'll pause this at 56 stacked images. And now what I do is I hit save. And when I save, you'll see across the top there, the green bar. This green bar shows that it's being saved as a file by the name of whatever .fits, F-I-T-S. That's an astronomical image format. But don't worry, it doesn't leave you out, because we also save as it's seen, just as you see it. And that's a ping file, which is actually every single application opens these files, these PNG files now. So you're not going to lose out. And if you ask about, well, where do you find it? If you look back in the chat, you'll see that Cypher 2 has actually posted the link to our server. It's a live server, and if you want to find it and you can't find what he said or she said, I don't know if Cypher's a guy or a girl. Oh my gosh! If you can't find it, it's a link that's a permanent link on my Facebook site, Mark D'Antonio, or SkyTour LiveStream's Facebook site, and it's up at the top, and it says, the server, and it's a OneDrive open server where you can all go and get the data, and you see weeks and months of data that's available for you to play with. So I hope you have a good time with that. All right, so that's how it all works, and I think that's pretty cool. Hey, Chris Johansson, how are you? Nice to see you. Yeah, and Cypher 2 is right on top of things again, posting that link. That's the link to our online server. You can go check it out, and you wade down into the directories. They'll be by date, and then you'll see that they just have numbers right now for tonight. But the previous ones have names, because I go and I change the names of all the directories to the things they are, so you know what to look for. Okay? So hopefully that is helpful. And that's sort of like your little tutorial for you. All right, and I was gonna ask a weird guy, how you doing? All right, we're gonna just do we'll do 1 second. All right. So now we're going to a mode, a special mode that allows us to see the sky. It kind of looks like a night vision mode, doesn't it?
It does.
Yeah, but it's just happens to be that color.
It's green.
I know. It's Daryl's referring to that Star Trek episode with Scotty where the Kelvins are taking the Enterprise through the Great Barrier at the edge of the galaxy to go to Kelva, their planet that's in the Andromeda Galaxy. And Scotty's job is to get the leader drunk so that he could help get the ship back from them. So there was this one scene where Scotty pulls out Saurian brandy, I think it was, and the guy looks at it after drinking like bottles of scotch and bourbon or whatever that Scotty had, being a heavy drinker that he was in the show. The Kelvin guy says, "What's that?" And as Daryl said, Scotty looks at it and goes, "It's," and he's looking at it, it's a green liquid. He goes, "It's green." So it's kind of really funny.
That was actually also a line in a Pink Panther movie.
Really?
Yeah. Inspector Clouseau is sitting at a stoplight, and some beautiful woman climbs into his car while he's stopped at the stoplight.
Yeah.
And he's looking real confused and concerned, and she leans over to him and whispers in his ear, "It's green." And she meant the stoplight, of course.
Yes, of course. That's funny.
She said it's green, and he gets this really weird look on his face,
and then he goes.
He realized she was talking about the stoplight.
Yeah. All right, let's see here. let's see if I can do this. And is that going to be north? I think it's going to be north. Yeah. So we're zipping down the equatorial lines here. You see those blue lines? And we're going to come to this cluster down here. Why not? I could just drive to it, of course, but I want to do it this way. Okay. And now we'll just slow ourselves down a little bit. Okay. Now let's head to the east a little bit. Yeah, I just think that, you know, if you're going to explore the sky, it should be fun, you know? We should have a lot of fun doing it. You know what I mean?
Who, me?
Everybody. Everybody listening. Okay.
Sure thing.
Yeah. So this is a cluster. It's a moderately rich cluster with about 150 stars. And there it is, right there. Boom. Go a little bit south, and we'll see it. Yeah, right there. So let's... oh, yeah. I like this song, too. So we'll increase it a little bit. What are you talking about, albatross around your neck?
They called you captain of the ship or something of the sort. Then Isabella said, I'm the spaceship navigator and the guy who knows everything about astronomy. I do not know everything about astronomy. Then Carol called me second in command, and Isabella said I'm not in. He's first in what he does. She doesn't like second in command. And Carol apologized. I said I'm the guy with the albatross hanging around on his neck. That's from Rhyme of the Ancient Mariner, you know.
Yeah. But you're not the guy with the albatross around your neck. You are a co-conspirator.
If you like.
Yeah.
I'm a regular Cliff Clavin is what I am.
That's okay. Yeah, all right. Let's zoom in on this little guy right here and enjoy the spectacle of a rich but somewhat distant cluster. Let's actually go see what the distance is to that young cluster. The distance is 3,718 light years, which is actually reasonable distance. What on earth is on, Dagger? So you're gonna hear my voice in both places? Is that what you're saying? That's funny. Yeah, I did many of the seasons of What on Earth. Now I'm doing Proof is Out There on A&E, and I just did an episode of UFO Witness, actually, yesterday. We filmed it here yesterday. It was kind of cool. Yeah, Daryl, that's a good idea. Scotty. But you got to get good with your accent, right? And say, "Aye, Captain. It's Scott here, Captain."
Or what Carol, I think it was, said, maybe, I'm sorry, not to drag this out.
Come on,
she was
having fun.
thinking like Star Trek, so maybe Spock. Spock has always been one of my role models.
Yeah.
I looked up Spock a lot, so, or Spock.
Mm-hmm. That's good. Okay, we're gonna go live stack this little cluster now and check it out. I'm excited. This is gonna be a pretty cluster. Oh, gotta clear this. Oh, dagger, you don't have to say that. I'm glad that, I always said, at least someone should say what's necessary. They should say that, the truth. And if I'm picked to do it, okay, fine. But you know what? As long as someone says it, dagger, that's the important thing. But thank you. That's very kind. Very kind. All right, so this is the beautiful cluster right here. Check that out. Now, see this modeling we're talking about? That's going to vanish as it gets more stacks going on here. As we stack more on top, that stuff gets averaged out. And then we'll be able to do some really cool work here. We're going to just dim this down a little bit here. So I'm going to grab this right there and pull it down a little. Because there's stars, we won't lose the stars. Oh yeah, look at that. That's pretty. Now let's get it out of there. Maximize. Boom. Yeah, there we go. Look at that. I like that. Come on down here. Here we go. Okay. Wow. Ah, dagger. Thanks, man. That's very kind. Let's zoom in on this cluster. We're at 50% as it is. Let me show you the size of the entire field relative to this cluster. Then I'll show you. Okay. So here is the size of the field. You see this? From this side to this side is 2 degrees of sky. That's 4 full moons. Okay. And we have 1.5 3 full moons up and down, 1.5 degrees. So that cluster then is it's less than the size of the full moon, but it's probably about half the full moon in size. But when we actually zoom in on it, we can actually see some more detail. Let's go to 100% on this and see what it looks like. Make sure it's still focused. Oh yeah, look at that. Look how beautiful that is. Wow.
It's nice.
You can see all the different colors of stars in here. Clusters, generally, like I said, they all have the same kind of stars in them. But depending on how far the clusters are, like this one was, 3,700 light years? There might be dust in between us and them. So some of the stars of the cluster might be behind some dust where others are not. So the stars can look at different colors because of, the same thing that causes the sun to be red on the horizon. Right? Scattering by, in the atmosphere's case here on Earth, molecules of nitrogen and oxygen. And in the cluster's case, molecules of carbon and interstellar dust. So either way, they get reddened. And so you don't have to have a cluster that's pure. You can have a cluster that has partial reddening to it, yet the stars are all the same kind. You have to basically figure. You have to figure that you're going to have to take this and adjust those stars appropriately, especially if you're doing actual research on it. If you're doing actual research, then I think that you need to calculate what's called the extinction on the stars, and that means getting to know a lot about this. The material between us and the cluster. Let's dim this a little. Not dim it, but darken the sky background.
Got a lot of red stars in that. Are your colors? I guess you've been talking about that with mentioning extinction. You got a real hot blue pixel over there on the far right.
And I actually have a hot green one right here. That's more than 1 pixel. That's actually it's a little streak on the sensor. You know, that it comes and goes. It's not always in the same place. There's a green one right here. See it? Yep. They come and go. Let's actually see. If anything, the sky is just a little bit too blue. You know, so we have to actually reduce the blue a little. So the red stars are probably reasonably accurate because I'm going by the black sky. See, I went to more green now, and you still see the red stars. So let's try this. Okay, that's probably closer. So let's get out of this for a moment and just check it out. Now look down here. See this right here? Now that could look like a streak to you, right? One of your voids. And we can see some up here too. It's possible that when the moon is not out, we'll find that this is actually dark nebula.
I believe that. Sure.
Lots of dark nebula. What are dark nebulas? Dark nebulas are these dusty regions made of dust, not gas. And they're made of molecules of stuff that was created when stars went supernova, or in the outer atmospheres of the stars when they're so big they actually could create carbon molecules out there. And a carbon molecule is black as can be. And so we see a lot of dark dust out there in the universe and in galaxies, you know. Okay, let's try something here. Let's see. See, we've already been going 1.5 hours just on clusters. I you know what? I really wanted to do this tonight because I wanted to see specifically how the telescope would perform with clusters on a moonlit night. Because we've done quite a bit better with this telescope. It's actually producing the best images it's ever produced. In the beginning when we did this, it wasn't producing the best images it could ever produce. Now it is. Okay, let's just see if we got our clouds. I know there's clouds coming. I saw them. Okay. We may have some clouds coming. I saw them approaching from this direction. This is the west over here. Okay, that by the way, that's our all sky camera. That's another asset we use, which is really cool. Let's see here. Okay. There we go. Oh, yeah. So we've stacked how many here are these? Probably 25? No, 39. That's more than enough. Okay, so now we'll save this. This is going to be a cluster night. I love it. And that's been saved, as you can see up there in the green. Now we'll save it exactly as you see it here. There you go. And then we'll get out of this and go back to our camera control section and go from 12 seconds that you see up there down to 1 second. Okay. And then increase the instantaneous processing so that it looks like it's almost like a finder. Okay. And you can see the little pixels that are dancing on the screen. That's the noise produced by the sensor. The sensor, if you look down here, okay, the sensor is at minus 10 Celsius. Do you see that? Right here. Okay, minus 10 Celsius. That's a very cold sensor. We're cooling it in order to eliminate noise or much reduce it. And when Isabella Melamed, who likes to do a lot of processing on our images, went to process out noise, she said, I don't see much noise. And she's right. There wasn't. Yeah. Wow. Clusters on a Moonlit Night. I know, that's kind of like a song by, you know, who's the guy that would sing it? Tchaikovsky. There's a crater on the moon called Tchaikovsky.
Say that again?
I said there's a crater on the moon called Tchaikovsky.
Am I missing something?
Yes. Carol Carl said, clusters on the moonlit night. It sounds like, you know, some type of a song, right? I mean,
Yeah.
and so I said yes, and it would be, if it existed, it would be by Tchaikovsky. Just because Tchaikovsky's got a crater on the moon. I'm linking astronomy into the craters on the moonlit, you know, clusters on a moonlit night.
What name are you saying? Tchaikovsky?
Yes.
Like 1812 Overture?
Yes.
Okay. I think I get it now.
Okay.
Never mind.
Thanks, Dagger.
I'm following chat too closely. It's evidently it's amateur comedian night tonight.
Oh, is it? Oh, about the, you know, I've had it with all these people. You know, I do this for the halibut, right?
Yeah.
Those kind of jokes, yeah.
I'm just scratching my head here.
I
I'll try to keep up. I'm sorry.
Oh, you're fine. Okay, we're gonna get out of this now and go to another. I mean, first, let's drop down to our auto framing so we can actually get this to be auto frame. There we go. Look at that, beautiful stars. And Charlotte, okay, you're gonna have to go. You got early plane in the morning, okay, or early plans in the morning, okay. Hey Charlotte, did you subscribe? I hope you did. I'd love to have you. You know, we enjoy everybody coming out here, and we have a lot of friends here, and we'd love to welcome you into the fold. So thanks for coming by, Charlotte. Love to see you again. So you have a good night, okay? All right. And Starseed's here. Hi, Starseed. Haven't seen you for a while. Okay, we're gonna go to NGC 637 now. Actually, maybe the fuzzy butterfly would be better. All right, it says it's somewhat faint. You know, we could try, even though it's a moonlit night, should we try the Fishhead Nebula in the heart?
Sure.
Let's try that. That's bright. The Heart Nebula may be a little bit too faint with the moonlit night, because we'd have to really pump up the gain some more. Okay. All right. Okay, this will be our finder star. What star is it? Well, we can go look. The handset should be illuminated. It's not right now. We're going to Seguin. And then we're going to go to the fish head. You'll actually see the nebula in this as we move, as it moves in, I should say. Been busy with SSP, Starseed? What's SSP? I don't know. I don't know what SSP is. Spock, what's SSP? I think we're talking... I think there's something here. I can't tell. Or maybe it's there. Well, we're going to find out. Again, when you don't have... I have the gain... it's there? I wonder if that's real or imagined. Could be. Let's actually go south and see if it comes in. Sometimes it does that. Okay, we're moving south. South is actually to the upper right in this, so see where the lines get bigger. Okay, let's just center that all up. Fish head, roly-poly fish head. Fish heads, eat them up, yum. And this is the Fish Head Nebula. Let's see if it's actually here. I was in information technology for 10 years, so SSP sounds like an IT program. Is that what it is? Katie Grabowski. Hey, look who's here. It's Katie. Yeah, there's the fish head. See? Hi, Katie. Nice to see you. I spent this past weekend up with Katie in Colorado. She's the director, as I mentioned. I already talked to you about you, Katie, earlier. Katie is the state director for MUFON, the Mutual UFO Network, up in Colorado. And she had me come in to talk to the Colorado MUFON group, and all a great bunch of people. Really nice bunch of people. Yeah. That's so good to see you.
What did you talk about?
Actually, the talk was about astronomy, and I was talking about the night sky. I was also talking about SkyTour LiveStream and what we do. And then I talked about some weird experiences I've had in my life that I can't explain. And it's all simply factual stuff. You know, not making any conclusions or jumping to any conclusions, you know. Okay, so we're going to put this here. And there's a whole nebula here, and it goes out to the field to the left. But we're going to try to look at the fish head. We may come back and fix that in just a minute. Okay, so let's go here. All right, we're going to do 20 seconds here. It's a little bit further away from the moon, so we should be okay. But we'll see. Off we go into the wild black yonder. Now this live stack comes up again. I'm going to clear this from the previous sky. And now we're going to have all we can do to control the brightness being too bright. But it's okay. Oh, there you go.
Yep, that's the fish head.
It is indeed fish head, yeah. I gotta stop doing that. Okay. And so the fish head now is right there. This is the Heart Nebula. And what we do is right now we only have two stacked. Okay, again, like we're taking images and stacking them on top of each other, and that gets rid of the noise in the background. So what I'm going to do now is come in here and try and drop the black level down a bit. It's a trade-off because when the moon is this bright, it's kind of hard to get this to work right. But we'll get it to work right. So that's too much. Okay, and you notice how it's brightest in the center? That is a function of the sensor itself. Yeah, we don't want that, but we don't have a lot of choice. Let's see what we can do with this. Let's try this. Process a little. Okay, and then let's grab this guy. It's probably going to make it redder. Yeah, but as you can see, it accentuates the brightness there. Let's now pin this, maximize this. There we go. And I'm actually in the way, so I'm going to come over here now. Oof, banged into the edge here. So over here now, you actually see the Fish Head Nebula right there. Okay, right there. And it looks pretty. Really, really pretty. Okay, I'm going to drop the red colors a little bit. Just drop it down. You can see dark nebula in here too. The dark nebula, those are like I said, those are the places where stars and planets will end up getting, will be born. you know, really interesting locations. Okay, let's drop this down now a little bit. Just to take the red down just a tad. There we go. That should work. Yeah, see? So I know we're focusing just to the right of the whole nebula, but I want to focus on this tonight. For a little while, anyway. Not bad for a 20-second photo, huh? Not bad at all. We're just waiting up for some of the frames to come in, listening to our music. Thank you, Vera. Vera says very nice. So, Katie Grabowski, how's it going out there in Colorado tonight? If she's still here. I don't know if she's still here. I feel like I'm floating in space. It's like, we have a lot of fun with this, right? It's crazy. This is actually what we're calling the Fishhead Nebula right here, this thing. And so that's the part of the Heart Nebula that we're talking about, okay? This right here is the actual Heart Nebula, and you can't see the heart because it's sort of over here. You know, so if we move it and look at it from a different perspective, we'll actually see the heart. So maybe we can do that. You know? Charlotte, you were supposed to go to bed now. You told us so, and you haven't yet. It's still a little bit bright out because of the moon, but we'll figure this out. Okay, let's try and just move it a little bit, darken it up just a little bit. There we go. And now we come in here again. Oh yeah. Alright, tell you what I'll do. I wanted to do the fish head, and now I have to tell you, I guess I lied, because now I'm going to go back and do the whole Heart Nebula, just to show you. Because some of you have never seen this stuff here before, so I'm not gonna keep this, because we're gonna come back and do another one. Alright, so we'll come out. See what stacking does? See how like noisy this looks? Well, did you remember how smooth it was as we started looking at it after it's stacked? And that's what the benefit is of stacking. Okay, Charlotte, good night. Thank you so much for coming. Hope you subscribed. Marianne's going to bed too now. I've been a drummer for many years, and this is the kind of song you just cruise to, just hang out. You can do solos in, just have a lot of fun. Oh yeah. Alright, let's go down to 1 second and move that cluster into the center. Okay, oh, see, even better. We'll get that back in just a minute. Alright. Make sure we take this down. Do hit that thumbs up, will you? Alright, now we're going to move that cluster over, so we're going to move this way. We're heading east.
thumbs up. I seem to remember hearing that YouTube is doing away with dislikes or something of the sort.
Really?
Hadn't heard that?
No. Oh, what a dummy. I have to go back to 1 second. Oh, I did. Okay, we're gonna do this guy and this guy. Oh, I'm so stupid. Sorry, I forgot to remove the stack. That caused problems. So now it's going to be really far over. Ah, yeah, it's almost perfect. Alright, my mistake, I apologize. That's too much. I like soloing to this on the electric guitar. I love playing blues on my guitar. You know, just one of many, many millions of people that like playing the blues. Okay, move this cluster in now. And I'm sorry I'm always bopping to the music here, I apologize for that. I play the piano, but I don't play it like this. I'm not one of those people. Okay, let's bring this up.
What are we doing, Mark?
I'm setting up the Heart Nebula, the cluster in the Heart Nebula, and I'm going to do it again. That's pretty good. I know that there's going to be a little bit of the fish head won't be included, but we'll be all right. Just move this over now. Okay. There we go. Okay. So do one more little movement, and then it takes 11 seconds to acquire the guide star. If you look at the telescope up there, you can see that it's actually pointing back up over its head, effectively. And that is pretty cool. So we're going to do 25 seconds now. And then clock out of this and go into the live stack. And I'll clear what we have in there if I haven't already. Clear that. Huh. That's funny. I would live stream. I saw a lot of people that live stream their guitar playing, and I just never thought of it. There we go. Look at that. Wow. There's the fish head right there, and there's the rest of the heart. It's bright because of the moon, but we're gonna work on that because we can. All right, my friends, we're gonna work on that here at WSTLS. This is STLS Live through the night, bringing you the best blues and nebulae throughout the universe. Stick with us. Okay, look at that. Tiny bit more. Alright. Now let's go check it out and let's maximize this nebula. There we are.
There you go.
Now that's the heart. Where's the heart? The heart's right here. See the top of the heart? Goes dotted, dips in, comes around, comes down. Right up there again. There's the heart. Or it's the giant snail. Okay, or the turtle. The head here, shell, and legs. Okay, and a little bit of a tail. Could be that too. Second. Okay. Fish turtle, Starseed says. Yeah, fish turtle, kind of. It's sort of weird, but, you know, it does appear that way, doesn't it? That's right. Fish heads, eat them up, yum.
Please, not again.
Hey, that's an earworm that I'm sticking in everybody's head right now, aren't I?
Yes, I know.
Don't worry, Daryl. You won't think of it when you try to fall asleep later. Maybe you will.
I'm warding off the evil eye here.
That's it. Okay.
We did that before you got here, Donald.
That's right. Okay, we're gonna do this, and now we're gonna just cut out some of the blue. Just a little bit more of the blue. That was too much blue. Stop! Dagger. That's hilarious.
Where does that come from?
What's that?
The fish head thing?
I first saw it on the Dr. Demento show. And it was a funny song created by this band that Dr. Demento featured on the Dr. Demento show. And it was really quite funny, and so I ended up kind of absorbing it into my head, and you know, singing it now and then to put earworms in people's heads. It wasn't that kind, was it? Because it really is an earworm. It definitely is an earworm. Okay, let's do this. And now let's drop the red. I'm just bouncing colors here a little bit.
It sounds almost like SpongeBob SquarePants.
Hey, SpongeBob.
Patrick. Hey, Patrick. Squidward.
Go away, SpongeBob.
Oh, it's Mr. Krabs, the Krusty Krab.
Okay, that's just about a little more. Just a little more. It might be too much. Yeah, too much. Pretty, but too much. And we actually don't use, what's the word I'm trying to say? We don't use the actual colors sometimes. Sometimes it's the artificial colors that show us more detail that we're trying to pull out. I wonder if this allows me to do this. No. Okay. Maybe this. Okay, maybe that's what does it. I'm just trying to reduce some of the blue now. You blockhead, Charlie Brown. Doesn't it sound like something like that? Like a Right? Doesn't that sound like a Charlie Brown thing?
What?
This song.
Oh, the piano?
Yeah, this is like Charlie Brown, like a Charlie Brown song from a TV show, Charlie Brown TV show.
Yeah, I can see that. This famous music from the Charlie Brown show is piano music.
That's right. Yeah, I love that song. I remember once wanting to try and play it on the piano. I never did. Yeah, it looks nice right now, Star, but I have to get us out of here just so we can... Okay, that's the full size. I want to give you the full size now.
You know, I could see the heart going all the way down to the bottom right, not just,
Oh, like sort of like a skew like this?
yes, that
Yeah.
point there at the bottom is like the
Yeah,
point of the heart.
yeah. But the heart center is here. This is where this goes down, this comes up.
Yeah, the cleft at the top is right
Yeah.
there.
I see what you're saying. Maybe a skewed heart. Christina Metcalf, how are you? And thank you for coming on out. And make sure you subscribe if you haven't. We'd love to have you. The more people we get, the more things we can add to the building and to the telescope. I mean, look what we've done. This is this is the moon. The moon is out right now.
Didn't we talk about Keith Jarrett recently, the piano player?
Was it Keith Jarrett?
It seemed like we talked about him recently.
Yeah.
The improv pianist back in the day.
Yeah.
Not still around. He did some really famous piano albums back in like the 70s and the 80s, I think.
Yeah.
I read somewhere that on the Cologne concert album, what really made him famous was they gave him an old broken piano. It had broken keys and was badly out of tune, and he improvised his way around on it.
Really?
He played that.
That's cool. You know what? I gotta tell you guys, yes, this is the Heart Nebula, but you know something? It really, it's compromised by the literal amount of light from the moon nearby. So when we look at this on a dark night, it's gonna astonish you with we see like literally about 80% more data and 80% more nebula. It's pretty incredible. Daryl knows. He's been here.
Well, I
Cool
was
stuff.
thinking if you're going to show the heart, maybe you should show the soul also.
Yeah, we can go to the soul as well.
I don't know if it could cluster stars in it like there is in this one.
Well, yeah, actually, let's do that. Let's zoom in because there's a few things I might want to show you in here. Let's go to 100%. We might have to move the field of view a little bit. Okay, so let's go here. Yeah, there we go. I think we're going to see what I want to show you. Now we come down a little bit. Okay, let's just maybe move like this. There we go. Okay, so this area right here with the heart, this is the lower left segment over here that we're seeing. I'm gonna move this back in a little bit in the center, and because I want you to see this. So what I'm gonna do is bring us down and bring the heart up in the view a little bit more. There we go. That's what we want. Now what I'm going to do is I'm going to bring up the live stack. Oh.
Oopsie.
Yeah, you heard it. That's okay. I don't care.
What was that?
Just a full can of something I was drinking. It was actually Coke Zero. I need the energy, the caffeine punch, but that's all right. So here's what I'm gonna do. Here's the heart, and what I'm gonna do right now is I'm gonna increase our black level a little bit to darken this up, because I want you to see something. You can kind of get an idea what it is now, but this right here will show up better. Okay. Now you'll see that this is not a very simple nebula. There's a lot going on here. You see these things here? Okay, these things sticking out, like there's a little thing sticking out right here. Okay, that's it's called a stalk. Okay, we see another one here. Okay, the hot cluster in the middle of this area, okay, which is right to the right over here. Right here it is, over here. This hot cluster has a lot of very, very powerful stellar wind. And these powerful stellar winds are actually pushing outward in the cluster. They're actually clearing a spot in the cluster here. As you can see, they're clearing a void. But they get to a certain point and they start pushing away the dust. This dark stuff is dust. This stuff here, though, this glowing red gas, is hydrogen. Hydrogen is the most plentiful element in the whole universe. And so we see that these hot stars are pushing on the dust, and they actually force it away. Okay, and what they do is they ionize the hydrogen atoms in the gas that's here mixed in, and it makes them glow red. Okay, that's a process we've talked about before. It's called ionization and recombination, but don't worry about that. The thing that's neat is the hydrogen glows red. It's a characteristic color we see with these star-forming regions, and these are stellar nurseries for sure. Okay, but if you look at this, in fact, I should do it this way. Okay, this guy right here, right? This is another example of a dark nebula that's being affected by that cluster over there, that's sending hot radiation this way and powerful radiation. And we'll notice that these things right here, they'll actually start to evaporate. It's like that one right there is like a little stalk. Well, the densest part of the stalk is at the very tip in this particular case, and the back side of it is sort of protected by that. So the radiation is striking this stalk, and it drives out stuff around the outside of it, but the stuff behind it stays, and it sort of ends up making these long fingers. You've seen this before in the Pillars of Creation, which is, the Measure 16, we call it the Eagle Nebula. But this, we see this a lot of places, these stalks like that. And it all has to do with these stellar winds and hot young clusters driving dust and gas forward and away from them because of their stellar winds. But these things that we're looking at here, especially these little guys here, what we're looking at here in particular is an area where we're going to eventually see more stars forming, because they're a condensation area. They're an area that's condensing gravitationally, and that's why they're more dense and harder for these stellar winds, these powerful winds, to blow them away. So I think that's pretty cool. And so this happens all over the universe, billions and billions and billions of time. So this is actually something very interesting. Anyway, so that is the little lesson on the dark. These are called dark nebula. A little lesson on the dark nebula. And if we actually back out, actually, I don't need to back out this way. I can back out this way. Okay. As we back out, we can actually see that there's more of these. Okay, and you'll find that they're like everywhere you look. Look at this. You can almost see the three-dimensionality of this, can't you? In this bottom of this nebula, it's really pretty. Here's another prominent stalk. Notice that it's angled toward the hot young stars. Now, it's not directly, because it could be an illusion. It could be that these stars are clearing some of these stalks away, but it could literally be that star right there, that one star whose radiation is pushing this away, and forcing this to be this way. It's a three-dimensional universe, you can't forget. in 3 dimensions. You don't know what this nebula looks like. This could be much further away. This cluster is probably seated in the middle of it, okay? But the middle of it being because the stars themselves clear an area around them that's fairly the same in all directions. But in this case, you can see it's not true. It hasn't cleared this area here, but it's cleared this area.
On that part, son?
This part here?
Yes.
Yeah, sure. That's a really pretty location. So we'll do that. We're going to move it over. Okay, we're at 59% zoom right now. We're going to just drop this down. It's really pretty. Even we have nearly a full moon out and we're doing this. So it tells you we've got some pretty good capabilities in this observatory. All right, we're going to go to 100% from 59%. That's really pretty. Okay, so you can see how these are areas of dense gas. Now, what might be in there as well is dark dust that you can't see because the glow might be covering it up. Okay, and here's some dark nebula in here. There's some more dark nebula here. Aside from all this obvious stuff here, there's a lot here. Yeah. It really is, even on a moonlit night. And actually, what I'm gonna do give us a thumbs up, by the way. Don't make that label come up in vain. Okay, let's actually go and just momentarily pull this up, and I want to move the black point over a little bit more. This is a lot. Yeah. But if you notice now, we're basically totally extracted the moonlight effectively. Go away. We extracted the moonlight effectively from this. So now we have just the nebula. And I know what you're thinking, guys. I know you're saying, zoom out so that I can see what the whole thing looks like. Oh, all right. Let's do that. Now you'll see it looking a little bit more clear. All right. Now, one thing that's happened is because we set that dark level for what's in here, we're missing a lot of the detail out here, okay? So when we're in different positions within the nebula, we would change that dark level, right? So I would come back some to bring back this other stuff you see. Again, that bluish haze in the middle, that's due to the moonlight going onto the sensor. Hey there, Corey Williams. Nice. Yeah, Venus is really pretty, Corey. By the way, thank you for joining us tonight. Make sure you subscribe and hang out with us.
If you watch Night by Night, Jupiter and Saturn are drawing closer and closer to Venus, too.
Yes, sir.
Yep. They should get pretty close together here toward the end of the year.
Yep.
They make quite a view.
Okay, so this is the center of that cluster again. Now you're talking about a distance here of several light years. You know, this is pretty cool. You know, several light years. And here's isn't it interesting to think about this? We're looking at a place in the universe where potentially at some point in the future, planets can form around some of these stars because of all this black dust that contains lots of other elements that make up planets, right? In the same way that we were formed out of a solar nebula, planets might be formed there someday. Maybe even happening now, but the thing is, this is a region of space that's really, really hot. Really hot because we have these stars with young hot stars in a cluster only a few billion years old, and so I think that we have to think about you have to really think about what's going on. The high ultraviolet radiation is probably going to keep things pretty sterile for a while, but as the stars move around each other, remember this is a snapshot in time of what's going on. all these stars, okay, that we see here, they're in this cluster, right? But they actually are gravitationally bound, and they'll move around each other, and some of them are going to get whipped out of here. Bye. Okay? And whipped out of here in other directions and other directions. And then finally maybe a few will be left. But what the problem is that those stars are hot and young. They're only a few million years old. So, and that is young considering stars last many billions of years, and some actually last trillions of years. Okay? So these stars in a cluster, these generally form a fairly hot, sterile area in the universe. Yet somehow, when they get whipped out and allowed to age, some of the stars, depending on how massive they are, they end up becoming homes for planets. And those planets become homes for creatures, perhaps, like us. So we're actually looking potentially at the birth of future civilizations out here. I think that's pretty cool. You know?
If you look at that one bright tongue hanging down, lower left to center.
Yes.
That one right there, yes. That bright star appears to be right at the end of it. I wonder if
Right
that's, really there, or if that's just a chance alignment.
It's a good question. I think that if this star was really there, then if it had any ultraviolet energy, then I would expect to see more of this lit up. But it could be much closer to us. It could be farther than from us. But if you look, guys, here's the thing to notice. You notice how you see a lot of bright stars. Okay, yeah. Those are stars that form the core of the cluster. They clear a lot of the gas and dust in the middle of the cluster and push it away from themselves. So there's a whole void that's been created here, okay, where the stars have been using their stellar winds to push out everything, okay. However, if you look elsewhere in this nebula, you'll notice there's lots of reddish-looking stars, right? And they seem to be associated with areas where we see this nebulous clouds. Well, what that means is very likely, very possibly, that those are stars that are embedded in this nebula. And within this nebula, as we know, there's lots of dark dust like this and like this and like this over here and over there. And that dark dust acts like a diminisher of the star's light, and it will cause the stars to be redder, just in the same way that the sunset looks red on our horizon because of the way the atmospheric molecules operate on the sun's light when it's coming to us from a longer distance through more air. And in the same way, through more nebula, the starlight is going to be reddened as well. And we call it interstellar reddening. And that's just what we're seeing here, potentially. But we're also seeing potentially some red dwarf stars, the most populous star in the entire universe. You know, we gauge stars by their hottest and bluest to coolest and reddest. Okay, which is O, B, A, F, G, K, M. Those are the classifications. And so these could be M-type cool stars, right? But most likely they could be stars that are like these guys out here, maybe B-type stars or A-type stars or F-type stars, which are not, they're whitish to yellowish, but when they get stuck in a dark cloud, then their light gets scattered. The high-end blue light gets scattered, and they turn red. And that's what we're seeing here, potentially. All right, Corey Williams asks, can you see color in space? And did you guys see the clouds of Saturn from the Cassini telescope? It's stunning. Oh, yes. The Cassini took some excellent photos of Saturn, and it took some excellent photos of Saturn's biggest moon, the biggest moon in the solar system, Titan. And that was really pretty. Saturn's clouds are interesting too, but the Juno probe, Juno, the Juno probe has taken pictures of Jupiter's clouds, North Pole and South Pole clouds, and the Juno imagery is spectacular. We're seeing... What?
Oh, I'm sorry. I was going to say, yeah, Juno. Some of those are really gnarly looking clouds.
Yeah, lots of blue swirls. Here's the interesting thing. Jupiter is almost all hydrogen. Almost all. So where do the colors come from? Well, they come from pollutants in the atmosphere. A very, very small percentage, sometimes less than 1%, is all you need to change some of the bands to red, like ammonium hydroxide and other compounds in Jupiter's atmosphere. that formed with it. And thus, when the equatorial bands and zones, as they're called, were formed, they had these pollutants in them, and the pollutants isolated in different locations, and you got these red bands, reddish-brown bands, brown bands, and then white bands, white zones. So it's pretty cool. Yes, and Jupiter clouds are majestic, especially as seen with Juno. And think about this: Jupiter, Earth is 8,000 miles across, and Jupiter is more than 10 times the size. So we're talking about a very large planet. You know.
The colors are also a reflection of how high or how low the clouds are they not?
Well, the colors are related more to the pollutants, what they call contaminants in the atmosphere. But you're right. The zones are deeper, the bands are higher. And the reason they're called zones is because there's convection going on, and it's bringing stuff up. And at the borders of the bands and the zones, you actually see turbulence. And thus you see all these weird turbulent eddies, which are just spectacular. You know?
Maybe we drop down toward the bottom of the heart.
Yeah.
I'm curious if you could zoom in on that, what I call the point at the bottom of the heart.
Yeah,
earlier.
let's do that. So we'll do the auto here. We'll drop down here to this, you mean?
Yes.
Yeah, that's pretty. All right.
And I don't know if you'd want to massage the settings on that in here or not.
We're going to find out. Let's go in and look. Okay, so let's head down here.
It's right on the edge of the image. I don't know if you'll be able to get in very much on it.
Down here? Oh, we can. Yeah.
See, I see another case right there of like stars forming along the edge of that cloud. Maybe again that's just chance, but
Are you talking about here?
no, on there at the very bottom.
Okay. Oh, right here.
Yeah, it's right there, all along that side of it.
Yeah. Well, that's interesting because it could be that there was some type of shockwave that came through here, because we don't have a history other than what we see and what have seen since we started looking at nebulae like this. And that's only a few hundred years of doing that, a couple hundred years at the most, actually. And the Heart Nebula was probably discovered, I'm going to guess, in the 1900s. But you could look that up. I think that'd be interesting to find out. And so it's possible, because we don't see the history, we don't know what happened here before. There could have been a supernova somewhere that at some point in the distant past blasted a shockwave through space, pushed this hydrogen gas into this position, and all along this area, that on the other side of this, maybe the interstellar medium was denser and it kind of snowplowed in, making it hot, and made star formation occur along that line like this. That's possible.
Heart Nebula was discovered by William Herschel on November 3rd, 1787.
Okay, so it was, but they certainly couldn't see it like this. That's for sure. They couldn't see it like this.
It's interesting. Can you zoom in on that anymore?
I can.
Maybe.
Oh, I can go 800% on this, but I'm at 97.
Well, just go 100 or whatever you were doing before.
Well, that was almost 100. I'll go to 125.
Okay.
Okay. We're starting to see some artifacts of the camera here.
Yeah.
And that's actually artifacts of the stack, not the camera.
Right. Because you're at the edge of the field.
Yes. You see what before it stacks, guys, what it has to do is align. So it takes an image, takes another image, and if you put it here, these would not align, but it has to align everything so that it's all exactly lined up. And by making the exact alignment, that's when you get a successful stacked image. So, but there is whatever drift occurs because the telescope is slight drift or whatever, then the stack will be off a little bit, and what they do is it aligns on all the stars, but the edge of the field where there might be some drift over time ends up sacrificing, and that's what we got down here. You see this little horizontal banding.
Isabella, I don't know if we could really say that the Heart Nebula is a supernova remnant. It's an emission nebula,
Yeah.
and I guess we'd call it a stellar nursery, but
Yes, we would. Yeah. Yeah.
no, I just think that's fascinating because, I mean, they're on the right side in particular, the stars following the edge of that curve.
Right there. Yeah.
There were a couple of other ones inside it.
Were there?
Yeah. Anyway, that's okay. You don't have to do that.
All right. And this blue glow here, again, is related to the bright moonlight that is coming in the opening of the telescope and making its way to the camera sensor. And we're still kicking out most of it. Okay.
Want to check out the soul while we're in the neighborhood?
Yeah, why not? You know, I love astronomy with heart and soul, so I guess I should, right?
Sure.
Yeah. I will pause this. We did, you ready for this? 76 stacked images here.
Huh?
But with the moon out, you know, it's better to do more. Okay, I save the stack, and now we'll save exactly as we see it. Okay, and let's see here. Alright, so now I can clear this. Come out. Okay, and just come back. I gotta check to see what we have for clouds right now, because I know there was some high altitude clouds coming in. You know what's weird? Last time we tried to do the Soul Nebula, we had clouds come in and we had to stop, remember?
Yes.
So let's see just how many clouds we have now. Let's go look, Spock. I would love to see. I just don't want there to be clouds. So we'll just maximize this big bright white. Boom. Sorry, guys. Okay. 2 seconds from now, we're going to find out. No, not bad. Not bad. I think we're okay. And I'll minimize. Okay. And now let's go here. Do this. Get our hyper process going. And then we come back and look at our planetarium. And just jump over to the Soul, shall we?
Please do.
We'll drive it over. Let's just not drive it, but we'll just let the telescope go there automatically. You'll see it change. All right, and we'll get out of this right here so we can watch the telescope moving. I always do that for safety. This song sounds like a Three's Company theme song, you know. Not really, but a song you might hear on it. Okay, so now we move in. There's never too much bacon. You could never have too much bacon. Well, aliens think we are bacon.
To serve man.
That's right. It's a cookbook. There's a Soul Nebula.
You ever heard of Alfred Packard?
Was that a character?
No, he was real.
Oh.
He was an infamous Colorado cannibal back in the 1800s.
Ah.
Back in the mining days. The University of Colorado in Boulder, they named the cafeteria the Alfred Packard Memorial Cafeteria.
Only in Colorado.
Yeah.
Why would they do that? That's they're immortalizing a cannibal. Ugh.
They call it colorful Colorado.
Yeah. I was at Red Rocks the other day, by the way.
Oh, were you?
Yeah. It was really nice. I've been there. Not been there, but I've seen it on TV. Never saw it in real life.
Yeah.
Yeah. Okay.
That's part of the so-called Morrison Formation, which runs up
The
and
red
down
stone.
the Front Range of the Rockies.
Yeah.
Garden of the Gods here in Colorado Springs is also part of the Morrison Formation.
Yeah, I'm supposed to go to Garden of the Gods next time I go, actually.
Well, if you do, let me know, because I'll have no excuse not to.
Well, I hope so.
Yeah.
That'd be great. Okay, move this up.
Garden of the Gods is cool. It's like so much Colorado. It's being loved to death.
Yeah. Hey, Curtis Horn. Curtis is with us. No, I'm actually, I collimated the scope, Curtis, and I'm back in Connecticut now. I had to go speak. I was teaching astronomy in the desert east of Phoenix, and then out in the desert west of Phoenix, working on the scope. Then flew to Colorado to do a talk on astronomy up in Denver, actually Centennial. And I was there for the weekend and came back home to Connecticut now. So I'm not there now. As you can see, I have all my other things. You know what I forgot to do? Can't believe I forgot to do this. Holy cripes. I actually can't believe I did this. All night long I haven't been saying anything, but I just don't believe I didn't do this.
What'd you do?
I didn't show what we're looking at. See what I mean?
In Stellarium, you mean?
No, right here, look. See? Right here.
Mm-hmm.
I have not been given the names of what we're looking at. I can't believe it.
Yeah, well.
Well, I'm stupid. I wanted to
You
show
sent it to the Soul, and now we're at the Soul.
Well, see, the Soul Nebula, that's right. Yeah, that's where we are. And yeah, again, we have this artifact from the sensor, and that's why we do things called flat fields. I do it synthetically after I get the imagery downloaded. And don't forget, this makes the this footage is all available. All these images are available on our server, our OneDrive public server, and you can come to the Mark D'Antonio Facebook site or SkyTour LiveStream with Mark D'Antonio on Facebook, and there's pinned posts at the top of each of those groups, each of my Facebook page and the other group, and they have the address of this server that you can go and check everything out on, and you can download all these files, so pretty cool. Yeah, SkyTour LiveStream. Make sure you subscribe to that. I mean, come on, you guys. Most of you are already. But if you're just here visiting, if you're lurking and not writing any text, come on. You have nothing to lose. It's all free. We don't hound you with anything. We're not one of those people. Well, a group of those people. Hey, Pamela Strutman, how are you? Nice to see you. See, that's a person who wasn't leaving messages but was watching. Nice to see you, Pam. This is the Soul Nebula, like as you can see. So we're actually we're hanging out here. Daryl.
I almost see a head in that one.
What?
I almost see a head in that. A face and a head.
Well, I see like the eyes and a mouth, and like these are like these.
On the right, ear on the left.
Well, those aren't ears. Those are antennas, man.
Okay. Kind of looks like a goblin's head or something.
Yeah, exactly. It does. I get it.
Little wide head, wide face.
Mm-hmm. All right. Hey, Pamela, make sure you subscribe if you haven't. Amal's here as well. Hi, Amal.
Well,
Yeah.
excuse me a moment, please.
Sure. That previous song that Genghis was saying sounded like Blade Runner. Very interesting because I work with the guy that did the visual effects on Blade Runner, Douglas Trumbull. And based on his effects, they tailored the music to the mood created by those visual effects. And so, in some way, no small way, the music was influenced by that. Neat. Oh, Monty Python's lifeboat sketch. I'd rather eat Hodges. That's funny. I'd rather eat Hodges, sir. Very, very funny. So let's zoom in on parts of the soul here and check it out, shall we? Yes, we shall. And then we can correct for some of the blue cast we have from the moonlight. But remember we talked about those dark nebula? Well, isn't this interesting? As we zoom in now, look what we see. We see this area right here. That's an area where there's a star somewhere. It could be anywhere in one of these stars. Probably not here, but something along this, down this radial, this point. And the star's stellar wind is blowing this dust back, but the reason this point isn't gone is because there's a density of material there that's self-contracting gravitationally, and that could eventually become another star and possibly planets after. It's really how the universe works, you know. So now we come over here and we see more hydrogen gas that's been excited to glow by this ultraviolet radiation, and we back out a little bit and we go to the other side and there's more of the same. Down below there's more. Okay, so we saw the Heart Nebula. This is the Soul. Okay, a very interesting place actually in this nebula. I just went a little too far. A very interesting place in this nebula is right here. Okay, you see that? That's another weird area that has been, we call it evaporated. It's been evaporated potentially by some really heavy-duty stellar winds blowing on this. Ote. So there you go. And that could be from a star like this star, or maybe that star, you know, evaporating it. We don't know. We have to figure that all out. You have to figure out the three-dimensional layout of this nebula. And that's no easy task. No easy task. Then we come down the bottom here. Okay. And here is a bright cluster that's in here. These two stars form a cluster of young stars. And then this whole area has been hollowed out by stars in the interior here. And depending on the density of the interstellar medium, sometimes that stuff could go out evenly in all directions, but sometimes it can go out and get stopped on one side but continue on the other side. So the stars that are doing it can be shifted to this side, yet the interstellar medium might be denser on this side, so the stuff the cavity doesn't get cleared as much or as easily as on the other side. So literally what we're seeing here, these stars right here could be fully responsible. They could be fully responsible for clearing this entire cavity, but it might be denser on this side. So their winds don't push the material away as easily, but they do on this other side. And that's something to keep in mind. And again, it's in 3 dimensions. And again, it's a time machine. Okay, everything you see in the universe is something back in time. This is the Soul Nebula. We went to the Soul Nebula with our our system here, and the Sol Nebula is 2,185 light years away, right? As such, at 2,100, 2,200 light years away, you could measure the distance knowing that these features in the nebula are this far apart. You could measure the size, the distance, and actually get their exact distance in light years to figure out how far apart they are. I have a program I wrote that does that, and I didn't want to bore you with it, but it's kind of cool to decipher that. But that's just a visual thing that you can look at and determine what the cluster and the nebula do with each other and the relationship between them. This isn't bad.
The Sol is 2,000 light years away?
2,200, yeah.
Wiki says the Heart Nebula is 7,500, so they're not even close to each other.
Yeah, if you take a look, well, here it says 2,185. Look up the distance to the Sol. Make sure that Stellarium is actually right. Actually, let me see what the Heart Nebula shows as a distance. Okay, the Heart Nebula shows as 2,511 light years. So clearly something's not right.
Yeah, well, you see them in space like that. I mean,
Yeah.
I would presume that they're close to each other, if not physically associated.
But Wikipedia is also notoriously wrong with things.
Yes.
And Stellarium is, well, also notoriously wrong with things. We have to look up,
Touche.
Yeah. So getting the right, but again, it depends who you talk to. It's logical to think of the heart and soul as being connected in space, basically. I agree with that. They are. However, the thing that's interesting about the heart and soul is that we don't really understand the full distance to these objects. We can get a rough idea, but the cosmological distance ladder mechanisms for finding a distance to a nebula like this are not as refined as, say, finding a distance to one particular star, because even that can fail as well.
Yeah.
So it's pretty interesting.
Wiki says the Sol Nebula is also 7,500 light years away.
Okay.
So take it with a grain of salt.
Yeah. Yep. Right, so that's like 0.7 kiloparsecs, right? Okay.
What, the 2100 figure?
Yeah. 20,
That
22.
sounds about right.
So let's do this.
1 kiloparsec could be 3,260 light years away. So
Right. Because a parsec is 3.26 light years. So 1,000 times that, right, is 3,260 light years. Something in the moonlight catches my eye, Genghis says. Something in the moonlight catches my eye. The shadow of a lover goes dancing by, looking for a little bit of love to grow. Give me love, give me heart and soul. That's really nice. Hi, Danny Johnson. How are you? The Pleiades are visible, but I don't know that we can see them with the observatory yet, because if you look right above my head, that direction is to the east where they're rising. But to the east in our view is the lights of Phoenix 65 miles away. You can't see them with your eye when you're there, but the sensitive cameras can see them. So I had put the eastern side of the building here. I put that there because I wouldn't care about looking in that direction. The telescope is also sitting to the right of center in the building, so they get a much better southern and western and northern view with much better capability. So these things, I just moved that, which I didn't want to do, but that's okay. I'll put it back. Okay. Here we go. Okay. Hey JSCO, how you doing? Yeah, see, Curtis is saying the same thing. Sky Safari, they all have different things, Curtis. Because it's very difficult to get distances to these nebulae. Sky Safari gives you a definitive answer that's maybe not correct, and Stellarium gives you a definitive answer that's probably not correct, and Wikipedia gives you a definitive answer that is most likely not correct. The best direction to go is to go to the SEDS database, go to the NASA database, and with the data center data, you go there, go to the CDS portal and start looking at things, and then you'll get the parallax, and then from the parallax you can, they give you parallax, as well, but you can get the distances there, and that's really a better way to do it, because that's the definitive answer, and it still may not be right. There's so much we don't know. We think we know so much, but we really don't.
Back in the day, they couldn't measure parallax on things that far away.
Yeah. Hey, David. David's here, D8V1D. How are you, David? Have you ever compared your nebula or other photos using the parallax method? Unfortunately, to do this, we would have to actually be able to measure the images we take in a very accurate way. For instance, we'd have to take an image on the other side of the Earth's orbit, okay? And when we're on one side of the orbit, we have to take a picture of the nebula, and on the other side of the orbit, we have to take a same picture of the nebula and see if there is any shift. The problem is that the size of the Earth's orbit, okay, is literally 186 million miles. It's really not big enough to show us a parallax to a nebula like this. With our conventional equipment, we would need to use far more accurate equipment, and then we have to actually do the measurements, and the measurement would be a fractional size of the stellar image on the image. Okay, so we have to basically get the center of the star image. I know this because I was in a parallax program working on exactly this. And you have to get the center of the star image. You have to exactly get the statistical center of the star image. But you don't do it just with one image. You do it with hundreds of these images. Okay? And so you got to take many images. And you get the statistical center. And you take the average of it over time. And then you do that again with the other view from the other side of the Earth's orbit, and you do the statistical center of those plates for those images that are taken at many of those. And then the difference between those will give you something called the parallax angle. That parallax angle is going to give us the parallax. And I think it's 1 over the parallax angle is the distance in parsecs, which is 3.26 light years. It's a parsec. So that gives you the distance, and it's accurate for stars out to about 300 light years. But when we're talking about nebula, we have to use a different type of parallax. There's not all parallax is the same. But that said, maybe we should do that, Daryl, on a SkyTour radio. We should talk about the different types of parallax we use.
Yeah, well, I was just about to say, the cosmic distance ladder, parallax is basically the first rung in the distance ladder, is it not?
Yeah, it is.
Yeah, and then go from there.
Yeah.
From there, I forget all the steps. I know Cepheid variables are a big one that Hubble discovered. Edwin Hubble, not the satellite, or not the observatory.
Yeah.
And that's how he established the distance to Andromeda.
Mm-hmm. Well, don't forget, we use different things as well. The clusters we're looking at here, like this cluster that's in here, this cluster right here. Okay, we study the motion of the cluster, and from the cluster's motion we can get its distance. That's called the moving cluster method. Okay, so there's lots of parallax and lots of different types of parallax we can use. So so that said, I don't want to overwhelm everybody with that, because the parallax is actually something that's a very interesting methodology.
Yeah.
And having worked in the parallax program, I can tell you that I use parallax to help me with my thesis. Anyway, I mean, we had distances to certain stars. My thesis was on stars that are speeding out of the galaxy at high speed. These are stars that might be whipped around and whipped through gravitational interactions, and they're leaving the galaxy. And they were called runaway B stars. Really cool.
You see up at about 10 o'clock in the image, farther out, that bright red lobe right there.
Mm-hmm.
It looks almost like it's being lit by the brightest star in that. And again, probably that's just a chance superposition. But,
maybe, but maybe not. Okay, let's zoom in on that, because there's something to be said about that. Okay, we don't know. It could actually be lit from a star that's hidden inside of dark nebula behind all this too, that we don't see. This is just cool stuff. Now, here's a dark nebula vein, right? It's sitting on top of a bright nebula block right here, and blocking the nebula behind it. So this star looks like it's lighting up this, but it could be lighting up all this. And this star could be the one responsible for doing that, or this star. I'm not sure,
Yeah. And you got the little dark nebula over to the right.
Oh, I love that. Yeah, we talked about that. That's a really cool little nebula that's over there.
It's almost like a bird's foot.
Yeah. And I think it's actually being evaporated by the bright stars over here, or at least reshaped over time. Very cool. All right, well, let's go out to the full size here. The size, and you'll see the lunar artifact as the blue halo in there. God, that's really bad. But you know what? I think I can fix that. This will tend to even it out. So this is a more even look at it, and it's gonna be washed out, but we can, we make adjustments to that, and we can do a flat field and remove all that glow, leaving just the data for the stars and the nebula behind.
I wonder, when you consider the whole nebula there,
Mm-hmm.
What we called the face, or the shape of the face, it's kind of a donut round shape.
Mm-hmm.
Was that stars in the middle blowing the clouds away, making that, or
Yeah, that's what I mentioned before. I don't know if you were here when I said. I think you were here when I mentioned it. I said these stars. I talked about how these stars here. Let me just go back to that for a minute. I talked about how these stars right here could be responsible for causing this cavity, and but then people would say maybe, well, why are they under the right side? There's a nice roundish cavity, but how come it's like, why are the stars here? Well, it could be because of the fact that the interstellar medium on this side would be more dense, and so the stuff would go out, but not go out as far, because the interstellar medium was slowing it down. But on this side,
saying that.
Yeah.
Sorry.
No, that's fine. But that's just what this could have been. That's why this hole could be here. Like the bubble nebula. The bubble nebula is a perfect example. The star is on one side, and the nice little round area looks like it's symmetric, but the star isn't in the middle of it. Again, that's that's probably because of the 3D orientation of the universe. It can be rotated a funny way, and it's probably got more dense material on one side, so that bubble of expanding material couldn't quickly penetrate that part of the interstellar medium.
Yeah. Well, if you look at the thing as a whole there,
Yeah.
the right side looks maybe a little more diffused to me.
Hmm.
And then if you look over on the left side, especially again up at about 10 o'clock, there's a pretty distinct kind of a edge to the wall there.
Yeah, there is. I
Not
wish
just on the outside, but on the inside as well.
And down here we have this beautiful peak from the stars here, probably starting to push material down and out and cause some material to glow here, and maybe evaporating some of this stuff. When I say evaporating, I don't mean evaporating like water evaporating. I mean radioactively disassociating molecules that may be in this area, okay, and pushing them away, reducing molecules to their component atoms, kind of a thing. Ultraviolet radiation has a way of doing that, because the other thing that's out in the middle of interstellar space is water, H2O molecules, and when ultraviolet radiation hits them, that will actually cause the hydrogen and the oxygen to be ripped apart. That's called photodisassociation. And
that's what happened on Mars, isn't it?
That's right. In part, that happened on Mars, making Mars lose a lot of its water in the atmosphere because the ultraviolet kept penetrating the atmosphere. Yeah. So, in any case, I think this is a beautiful little nebula, and we'll pause it here, and we will keep going. Okay, we already did pause it. That's good. And I think I saved it, but I forget, so I'm going to do it again.
Thank you for indulging me.
No, that's fine. I think it's all great. Everybody likes all this stuff. Okay. Let's go out of this and get back our... Oh, maybe not. Yeah, see, it didn't quite go. Here we go. Okay.
Well, what next?
I don't know. Let's go see.
Why do we end up looking at nebulas?
Well, it turned out that we could, which is kind of cool. So, that's what we're going to do. We're going to go and look at another cluster or two, because we saw them there. They were there, so we wanted to do it. Okay. What about the lawnmower? Okay, we're going to the lawnmower cluster now. You can see the telescope moving now.
Lawnmower cluster. That sounds like a Stellarian name if there ever was one.
I don't know. I mean, I don't think these... I think that's probably from some catalogs as well. I don't think Stellarian made up names.
A couple hundred years ago, they would have called a lawnmower a sheep.
That's right. Boom, boom. Okay. So we're gonna center that star and move over to the lawnmower cluster, moderately rich cluster. There it is. Look at that. That's a beautiful.
Pretty nice.
It is a beautiful little cluster, isn't it? Okay, let's head west a little bit. Bring it into the view, center it up. There's some nice orange stars down here at the bottom. Okay, now we'll actually do I'm guessing 12 seconds on this will be fine. Okay. Now we'll go in. Clear the last. Okay. got? Here we go. We got our lawnmower cluster looking pretty. Let's do a process on that. Okay. Drop the red a little bit. A little more. There we go. One more. Okay. Now we'll pin this and we will watch and enjoy and go to full screen. Ready? Boom. Oh, we got a second cluster up there, Daryl.
Okay, give me just a second.
Let's go see what that cluster is.
Those two bright reddish stars are supergiants. I was reading about it. I googled lawnmower cluster.
That's
It actually came up, but
yeah, I'm not sure.
663, which you have there.
I'm wondering if that's the butterfly cluster, fuzzy butterfly, up top here.
Huh.
We have a cluster with nebulosity here. And we have a cluster here. Yeah.
You know, the two bright red stars at about 5:30 to the lawnmower.
Right there.
Those are Those are supergiants.
Okay, so those aren't in the cluster. Those are foreground objects, most likely. And there's a couple more here. Let's actually go find out. We'll come back to here. We'll zoom our butts into this one. These are those two stars that you're talking about right there. This star. Yeah. Okay, it doesn't actually have a okay, yeah, no, it's the this particular application doesn't have any more data about those stars. Oh well. Okay, and the other side of this is the fuzzy butterfly, so that's got to be the fuzzy butterfly. But then this one has some nebulous inclusions in it. Beautiful nebula. It's right on the opposite side of those two stars. So that's IC 166 then. IC 166. Open star cluster. Yeah, that's got to be it, don't you think?
Let me look. I was reading still.
Okay. I think IC 166 is...
Let's see, our view is inverted. So bottom right would be top left. Looks like.
On the same side of these two stars, in our inverted view, we have this little cluster. So if we go to that right there, we go to the top right there, we've got the yin-yang cluster there, and that's probably what that is. But then we have with this cluster here, the lawnmower cluster, we also have in the upper left, we have IC 166, which I think is this guy.
Yeah.
And then, so the yin yang is above, and the fuzzy butterfly is on the opposite side of those from the red things, the red stars. And instead of the bottom, so that's going to be in the upper right.
Yeah.
And so the upper right here is the fuzzy butterfly.
Okay.
So we have IC166, we have the lawnmower cluster, we have the fuzzy butterfly, and we have the yin-yang cluster. All in one view, we got 4 great objects. Right?
Sure do.
And I'm going to adjust the red.
Top left sure is red.
Yeah, that's actually, I think, it looks like a nebula. Mission nebula. But it may not be. Actually, I have to check that out a little more detail.
Isabella says, I assume she's talking about the lawnmower. Says it's the most unromantic name of a cluster I've heard. Maybe that's what I was getting at.
Yeah.
Sounds like a 20th century sort of name.
Yeah.
Or a home improvement store sort of name.
Yeah, and why would it be called a lawnmower? I mean, what in God's name inspires you to think this is a lawnmower?
Yeah.
Maybe these linear features here? I don't know. I think there's dark nebula in here too.
Oh yeah.
I think there's some here. Without the moon we could see it. And I need to knock off some more red here. I'm always normalizing the sky to be like a shade of gray or black. Oh, I think that did it right there. That's better. This might be red nebula here too. We don't know. Let's go up to 100%. We're at 32% by the way, so we can actually get smaller. At 100%, let's check our focus. Good, our focus is still great. Look at that.
Yeah. You see diffraction spikes around that bright star.
That's right. That's right there. Yeah. And now let's go auto, and so you can see the whole frame. Now there's the whole frame. That's a pretty location. Look at this. This is amazing. So now when we look at this, guys, everything we're looking at here, these are young hot stars. These are all young stars. The clusters, when you see clusters, they're several million years old, and they're in a cluster because they're formed there, and then they're all going to have gravitational interaction, which kind of whips them out eventually, perhaps, and they move along like the sun did. The sun was born in a cluster of stars. And astronomers have been actively, not me, others have been actively trying to find our siblings, and the siblings that we looked for were those that were stars that actually had the same composition as us, and I mean identical, not a little bit, but identical, because we're all made in the same star nebula, basically, that our siblings were. Okay, so any stars that were made in that one nebula will be identical, and that's what we're looking for, and we found one. It's in the southern hemisphere, though. From us, we can't see it. But it's a really interesting star. All right, well, I think this is neat. See, it's like even when we try to go to something kind of, simple, we find ourselves finding something interesting going on.
Oh, we can make anything complicated.
Okay. All right, so that's the end of this. We're gonna be done with that guy. Again, everything's saved out to the server. You're gonna get all the clusters saved out, so you can have a ball looking at them, and you get the pictures. If you want to just get a pretty picture, you can take that too. Okay, so let's bring this up now. Okay, go into our hyper-processed mode here. Jump to our this beautiful object here. See, I didn't put the name again. I don't know. Not sure what I'm thinking. I don't think I'm thinking. Wait, what's that?
Object of unknown nature.
I guess so. Well, should we try and look at it?
Sure, why not?
I know, right?
Be small.
Maybe. But we have the ability to zoom in now. And it works. Object of unknown nature. That almost sounds like that almost sounds like Stellarium, like cheapening out on trying to actually find out what it is. Engage, Cypher 2. Mr. Cypher, take us out of here. Warp 1. Yeah, well, you know, we figured we're going to see much. I can't tell where the object would be in this frame. Oh, Carol and Isabella. And Star, what were you guys having a disagreement in my chat? I don't think so.
John Wayne said, never apologize. It's a sign of weakness.
Yeah. Right. And if you want a divorce, don't ever apologize.
Love means always having to say you're sorry. Excuse me, never having to say you're sorry.
Okay. Yes.
Right.
Kind of knew what you meant. All right. Let's, I have an idea. I'm trying to...
I wonder if there's a John Wayne Nebula.
Oh, that'd be funny, huh?
There should be.
All right. We're going to try this, even though...
You've got an M object there, M103.
Yeah, I saw M103, all 4 stars or 5 stars. M103 doesn't have a whole lot going for it.
Maybe Messier was out of focus that night.
Yeah, we can do the Pac-Man.
Okay.
Why don't we do the Pac-Man? Because we have never seen it perfectly collimated.
Okay.
I got you, Carol. Yeah, so we're going to move up to this star here. Here we are with that star here. It's called Achyrid. And then we're going to move to the Pac-Man Nebula, which will be visible. There's Achyrid. Maybe it's Achid, I'm not sure. Or Achid. Not sure how to pronounce it. Oh, the stars here. Sorry. First yawn. That's dangerous. You know, never be too tired to drive a telescope. So you see the Pac-Man here in a minute. You'll see this fuzzy thing come in.
I love humanity. It's people I can't stand.
Bark, 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 bark. I'm not sure it followed the right path. Yeah, see, sometimes it does this. But I'm not worried. We'll figure it out. Let's see. We go south. Okay. So we're going to do this. And this. Okay, and now we go south. We'll make some good time across this galaxy. There we go. Well, that's too much good time. Let's get back.
I see Starburst Galaxy down to the lower left in Stellarium.
I see that.
We looked at that recently, didn't we?
Maybe. Maybe
we don't
we
need
did.
to do it tonight. But just that rings a bell. I want to say that's one that Curtis Horn recommended to us.
Not sure. We looked at the that C5 galaxy and that face on. Isabella did a nice job, by the way, analyzing that. Not analyzing, but processing it. It was very nice. Okay.
Maybe the one I compared to like a smaller M33.
Mm-hmm.
It's like a face on spiral.
It was.
Heart-warming region.
Yep. It was a definite face on. Okay, we should see the Pac-Man in here now. And there it is. So let's actually bring the telescope over a little bit. Okay. Yeah, we're going to lock down a smaller speed and bring it over. And then we're going to move it up a little bit into the view. This is going to be pretty because we have never seen this in a really nice focused manner. So we're going to be doing this. We're going to do 25 seconds here. This is, the telescope needs 11 seconds to obtain a guide star. So by the time we get our first one in here, it'll have the guide star. Okay, so this is the Pac-Man Nebula. And I need to clear this. So here we go. Yeah, there's the Pac-Man, all right. And this keeps creeping up. I don't know why it's doing this. I don't like that this bar keeps creeping up on me. It should be down here. Okay. Clearly the Pac-Man is pretty bright. And what we'll do is first of all, we're going to actually just try to do some processing on it. That's going to help. There we go. Look at that. Then we're going to increase our dark level a little bit, tiny bit. And we're going to reduce the blue level tiny bit.
What's your exposure and gain set at now?
I will tell you in a minute. Let's actually, I got to come back up here now a little bit. I need it up just high enough to get to these guys. Let's set this. That's right, it's going to do that. And then we just drop the red a little bit. One more, maybe two more. One more. There we go. Okay. So now, as Daryl had asked, the gain.
Just curious.
No, that's a good thing. I'm actually going to also do something else. I have to put on our enhancement. I want to add unsharp masking. So watch this nebula now, guys. It's getting a little clearer. Wow, see how sharp it gets? That's really good. Look at this thing up again. What is going on with this thing? Okay, well, let's just get out. Okay, and then we'll mask it. Let's go full size. There we are. There's a Pac-Man Nebula. Look at that. Yeah, and let's zoom in on it, shall we? Actually, let's zoom in this way. This is the first time I've ever seen the Pac-Man really, really focused. Gosh, that's beautiful. Really pretty. Yeah, Curtis, we were talking about the Caldwell objects you had steered us toward the other night. I had never seen some of those Caldwell objects, so it was really kind of cool. There's a nice face-on galaxy you steered us to, Caldwell 5. It was nice. Look at this. Really good stuff here, man. Let's zoom even more. Because we can. Hold on. Wow. Play with the black level now. After I get this thing to drop back down to something normal. I don't know why it does that. Okay. And let's go over to the histogram, which is just a fancy word for the data. And let's take this one here, which this tells you where how black space is going to look. They're going to move it over a little bit more to make space look blacker. A little.
Histogram sounds like something you'd take for a stuffy nose.
That's true. Okay. Yeah. So we'll drop out of here. And I'll move the label a little bit. So that's our Pac-Man Nebula that we're looking at right now. It's an emission nebula. So there we go. And the noise level will drop. If you think about it, guys, it's nearly a full moon, and we have a gorgeous nebula that we can view, and the cluster within it. And again, this cluster is hollowing out the inside with its stellar winds, it seems. And if you notice right here, another one of those stalks. Now we can't see which direction that stalk is going. It looks like it's sticking out toward the stars, but it might be going, if the stars are farther in, it might be aiming down in. So it might not be this way, it might be like this way. We're looking down the length of it, projecting down possibly.
Can you zoom in on that?
I sure can. I'm gonna.
It's like another one with a star right at the end of it.
Yeah. That's right. So let's do that. Let's zoom in a little bit.
And the one down below, there's another one.
Yeah, this particular nebula has a ton of them in there. Like this one here. Okay, see that stalk? That's kind of like a pillar of creation. There's one here. There's one here. There's this dark nebula one here. And
the one over at 9 o'clock, it's bright on the end too.
Where?
9 o'clock.
Oh, over here. That's the one I was pointing to before, yeah.
Yes.
Yeah.
You see the star just outside it, and then
yeah.
there's the dark column, and then the Sort of like a bright cap to it facing the star.
That's right.
It's interesting.
Yeah. Again, similar issue. Evaporation that's occurring. I'm gonna just play with the black point just a little bit more because I want to probably drop this down to about here. I think now we're looking at something nice. Look at that.
Yeah.
Wow. Gosh, I love this. This is so cool.
I wonder if the little star just to the right of that cap on the one at 9 o'clock, if that little star could be lighting it up, or the big bright star above it to the upper right, or there's another dim star just above that cap.
Yeah, we don't know where these are relative to any of this, so it could be that tiny star doing it.
Yep.
It could be this star. It could also be these stars here, where they're combined ultraviolet light energy hitting that. I mean, something had to make this column start to evaporate, but there's a dense area up here that's gravitationally contracting that would have been evaporated long ago and pushed away if it could. Wow. This is the best view of the Pac-Man, and it's nearly a full moon. Just imagine how much better it's going to be.
If you follow the shape of that, the line of it, it's pointing at both the little star just to the right and the bright star far to the right.
Yeah, that's right. This star here and then this star here. But are those stars in line with the thing or not? And maybe it's neither of those stars.
Oh, exactly.
It could also be like one of these stars out here that's causing it to do that. And we can actually figure that out eventually. But it's just stunning. Folks, let me, I have to just step away for a moment. I shall return in a minute, okay? I'll be right back,
Okay.
Daryl.
I'll try to entertain them. Oh, this is beautiful. And if you look above that little column that's at 9 o'clock, two little dark splotches, I assume are Bach globules or something of the sort. There's just tons of detail going on in that. And the dark arm down at about 6:30 from the brightest star. It's got a very red star at the tip of it. That might be a chance superposition also. That's gorgeous. And the dark cloud that makes his upper jaw of the Pac-Man. There's some red crenellation along that top jaw, sort of at about 4 o'clock to the brightest star. I'd like to zoom in on that. That really looks interesting there. This whole thing is just super cool. You're talking the dark cloud at about 10 o'clock from the brightest star, Cipher 2. It's a dark cloud of some sort. I don't know. Mark could say better than I could probably whether that's actually like a Bach globular or if it's too big for a Bach globule. That's why I was thinking those two little ones over on the far left might be. They're pretty small. It's certainly a dark cloud though. And the top of his jaw, his whole mouth is a dark cloud too. They are Isabella. Whole thing is really beautiful.
Sorry, I had to get my coat because it's a little chilly.
I can feel it getting chilly here too. Cold front's coming.
Mm-hmm.
Did you clean up that Coke you spilled?
No.
Is that a full can you said or an empty can?
It was a partially full can.
Oh. I forget who that was. Donald Kunzer or somebody said if you didn't get that in 10 minutes, you're going to have a mess.
Mm-hmm.
That's all right. Phosphoric acid's a good cleanser.
What'd you say?
Phosphoric acid is a good cleanser.
That's true.
So much going on there. That's a trippy image.
Right?
I was saying while you were gone, if you see the dark cloud where it makes the upper jaw of the Pac-Man, like where his teeth would be, all that along there, at about 4 o'clock in the brightest star, there's a very red area. Right up along the edge of his jaw there. Just a little bit to the left of that, yeah. To the left of that, just a hair. That right there.
Mm.
If we could zoom in on that whole area, maybe.
Mm-hmm.
A lot going on in there.
Yep. You're right.
I see two little dark globules over at the left at about 9:30 from the biggest star. Two little tiny ones, 2 or 3 of them.
I'm
Are
here.
they Bach globules? Yes. That's one. There's another one and another in between them. Are those Bach globules? And then Cypher asked if the big one, where Pac-Man's eye would be, is that a Bach globule?
I don't think this would qualify as a Bach globule. The smaller ones might. These might be a little too big, you know.
I guess distance matters too.
Mm-hmm. It does. And this guy here is probably about the same as the others. Let's go find out. It'll be off by the same amount that this was. Let's see. The Pac-Man. Yeah, it says it's 5,500 light years away.
Lafitte's Grand Isle. That's a pretty cool name.
Yeah.
That's a classy name right there.
It is.
Lawnmower Nebula. Even Pac-Man. I mean, when did Pac-Man come around? Maybe they called it Lafitte's Grand Isle before Pac-Man became a thing.
Maybe, but Pac-Man, the name has been around for a long time on this. Maybe from the 70s.
Yeah, from the video game.
Yep. Well, maybe not. I mean, why was Pac-Man named Pac-Man? Maybe it had to do with something else that had a historic importance.
That's true. Yes, says the bell. I remarked on that red star earlier.
This one?
No, down right in the middle. Right there. That's another one. It's like it's the tip of a dark cloud.
Mm.
Very red.
Yeah, now, see those? Those could be red dwarfs, or they could be stuck in the dark, you know?
Yeah.
I think they're, because of their brightness, though, you can see, like, these stars are diminished, okay? So that means that they're probably in the nebula. This guy's pretty bright. It might be behind the black and be interstellar reddened a little bit. But this one looks like it's fairly prominent. I'm not sure. But in general, they're cooler than the stars around them, so they're not going to be as bright.
Yeah.
Look at this, wow.
Since you zoomed in some, that column over at 9 o'clock have several stars
Right there.
along the edge of that one too. Yeah.
Yeah.
It's almost, when you see that zoomed up now, that what I called a cap,
Mm-hmm.
looks sort of like it's just the bright edge being lit up by something or other
Well,
above it or to the upper right.
yeah, that's a
Sort of like maybe what we see with the Cygnus wall.
yeah. Mm-hmm. Got more of it
Or
here.
the back of the Pelican's head.
We got more of it all along here. It's all part of the same structure.
That's too cool.
I'm gonna cause the sharpening to come up a little bit. Let's go really high so you can see what that looks like. You can see this is, you can tell this is too much sharpening. I'm going to go all the way to the max so you can see. It'll show better when I zoom out. You'll see how, see, it's just too sharp. Everything is really sharp edged. So what you do is you work back and you come back. All right, Curtis, we'll do Caldwell 10 if it's nearby.
Go for it, Isabella. What's your question? Crazy cosmological question. It's alliteration.
It's pretty good.
Those are the best kind.
Yeah.
Got a very bright, very red star up at upper right of the whole nebula there, yeah.
Yeah. I knew her writing, Isabella. I can tell. Huh.
I suppose the conventional answer would be yes. That we have no special viewpoint. The laws of physics are the same every place and at all times. Modern cosmology, I don't really know though. I mean, when you throw in things like cosmic inflation, which is another one of those things I don't believe in. It's like dark matter and dark energy. I think, that's...
Well, you
how
can't.
many angels can you count on the head of a pin?
But dark matter you can't lump with dark energy. They're two different things. Very, very different meanings. Very, very different genesis of.
Oh, I know.
I don't think like the word dark. I think that's what it is. Because it's unknown.
Yeah, I agree. But as a general thing, I guess I would say the laws of physics were the same in the past as they are now and as they'll be in the future.
Yeah, I'm actually, yeah, that to me is true.
That may be a Newtonian sort of old-fashioned view, or Hoyle or somebody, but it would seem to me.
Yeah, I think that the physics we know today is the physics that occurred back then. The thing that we don't know are, for instance, we don't know the specifics about gravity. Okay? It's that simple. We don't know. There are different explorations as to what gravity is. And Curtis says they're both symptoms of the inability of people to solve general relativity equations. Haha, that's true. It's funny. But only if you've ever dabbled with relativity. Other than that, people don't get that joke, unfortunately. But he's right. Let's see. And Sabine is actually... she's pretty cool because she... excuse me. Sabine is pretty cool because she actually addresses these issues in a very nice way. You know, she'll talk about things like that.
She's actually got a rather high wit to her too, which may miss it. I mean, she's doing it.
Okay.
She's kind of funny.
Mm-hmm. Yeah.
She likes shooting holes in popular theories too.
Yeah, she does.
She loses me when she starts talking about elementary particles.
That's probably because you never had a quantum mechanics, a proper introduction to quantum mechanics. Yeah, all you gotta do is there's protons, electrons, muons, gluons, and so on. So that's all you gotta remember.
Yeah.
Okay. Okay. Okay, Curtis, I'm looking for... Oh, hey, Crystals and Cats. I just see you there. Very nice. Welcome. Good to see you again. Curtis, what was the name of that Caldwell object? Caldwell 7, okay. Let's go see if we can find Caldwell 7. I like doing requests. It's the all request hour. All right. And where is this? Oh, geez. Let's see how high above the horizon we are. Ooh. M81 and M82 are remarkably close. I have to spin around the other way for this one. I guess we can try it. Let's try it. But not until I get the telescope prepared. Okay. In the building here, you're looking at a spider web here. Okay. Now, let's get this going. And let's go. See if we can do it. Telescope's gonna whip around and it's gonna spin around and around and around. Round, round, round she goes. Okay. Let's see if it's within range. Oh, it looks low. Unless it stops now, we're gonna whack the, not whack anything, but if we get a star, yeah, that might work. Because it's gonna be higher. So it's going there, but it's going to go up there. So it's going to go up higher, which is good. So there's our...
That's your guide star, right?
Yes. And there we go. And now we go up, and the galaxy should be right there. And it is. Okay. It's always best, Curtis, when it's moonlit, moon-free night, of course. Okay. So let's now just bring this up in here. I'm really just very happy with how the telescope's performing. I really am. Yeah, it really is nice.
Figure out how to get rid of the halos in a timely manner, and you haven't made.
Yeah. Okay. All right, so here we're gonna do this now. We'll try this out. Let's say,
Okay, well there. I see your gain is at 250.
yeah. I mean, I'm leaving the gain at 250 for tonight because of the moon.
I understand.
So
I'm just curious.
yeah, that's why I put it at 250 tonight. So far, it seems to be working. All right, let's go to the live stack. Clear what we gotta clear.
Did you save it?
Yeah, this I did, yeah. Okay, and now we're going to be heading into the Caldwell zone.
Lower gain and shorter exposure.
Oh, yeah, look at that. That's pretty cool. Yeah, we'll be able to zoom in on that. That's cool. We can actually see. I want to probably. We're gonna stack a couple before we actually start trying to process. Okay, there we go. Let's do this now. We're gonna just do a little processing. All right, that's kind of what I expected. Now we'll actually zoom on this and see what we have.
Curtis says this can be seen in binoculars.
Okay.
Make me wonder if it's one of those white and messy you miss it.
Hmm. Wow, there it is. Okay. Let's slide the black point a little bit to the right. Okay. And then we're going to take down the blue level a bit. Okay.
Tail red.
What?
Oh, Curtis says he used to find this in binoculars in the tail red.
Oh, yeah. Yeah, the Telrad site.
I think I have a tail red around here someplace.
Look at these streaks.
Uh-huh.
I wonder if we've got clouds. I'm gonna go do an exposure and see. One acquisition. Here we go. There are clouds coming. I know I saw them. That's a pretty galaxy, though.
It is.
I think, not sure. This could be just a reflection. Alright, let me, I'm gonna go full screen here for a moment. Well, we have clouds coming. There they are. So I'm not sure if any I think we might have a couple that may have made their way in. But that's okay. Let's get out of this. That's bright. It's the burning of my eyes. Okay.
Clouds to your west and southwest.
Yeah, I see them.
They look like they're moving toward the north too as they come east.
Mm-hmm. Okay, so let's do this. Alright. These streaks right here are definitely high altitude clouds interfering with our image. But you know what? Let's just keep going a little bit. What I love is that we could never support zooming in this much on an image in the past. But now we can.
It's one to come back to on a dark night.
Yes, it is. But these streaks, you know, are ruining the image. So it's like not worth doing it right now. Yeah, the moon's bright.
You got stuff going on all at the upper right part of the galaxy, and
Yeah. I mean, that looks like a giant H2 region.
I see a streak to the upper left.
Yeah.
And some farther to the lower left.
The galaxy's being perturbed by our atmosphere. Hello, meteor. Hello, meteor. So, did you hear about the... Remember that? Meteor? Ah, the atmosphere. Ah, the atmosphere. Ah. Remember those commercials?
No.
How about this? Buzz, 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 buzz. Hello, mosquito. Hello, mosquito.
Sorry.
Okay. Someone in the chat will remember. It was a .com commercial. Yeah, it does kind of look like a mini M33. And it could also be an SC Sparrow, I guess. I don't know. Maybe it was. Let's go back and see what Caldwell's 7 is. It's an SAB. Okay. So it's not an SC. Interesting. Very interesting. But stupid. Remember that? R.D. Johnson.
Yes. Laughing.
Mm-hmm. Where we saw for the first time Tiny Tim. Tiptoe through the tulips. What's going on there? Oh. And Curtis, you're right. The color balance all has to happen. But the fact that we can do it with a nearly full moon shows the, the value of the filters, I guess. We are using a UHCS filter, Curtis, and what that is, folks, is it's a filter that allows only a narrow band of certain wavelengths to come through, but 3 of them, 3 bands. So we get the red of the nebula, we get the bluish green of the oxygen glow that we see in the planetary nebulas like the Dumbbell Nebula, and we get the other hydrogen beta, which is another line that's very common. It's not like a sulfur line, but it's similar, and so that gives us a wonderful way to take our images and produce a beautiful image, even when there's a lot of light out there. I'd love to invent a way to image deep space in the middle of the day. See, Curtis, this is a little better color balance. See, check this out. See, that's better color balance. It's a little bright. So we can adjust that by taking the dark down a little bit. The black level. So that's pretty cool. That's about, yeah. Well, I love Hogan's Heroes or C&D Boy, Canada Boy. Yep. Curtis, if I do an auto color, it's gonna bias it toward the blue tremendously. So that's why I've been avoiding that tonight, especially within SharpCap. The SharpCap's the name of the program we're using, guys. That runs the camera and everything. So that's what I think is causing this this coloration here. Well, I can do it because I can always bring it back. So all I have to do is just see where we are with the levels here. But if I do the color balance right here, watch. Boom. Okay, blue. So I can undo it. I can do this color balance. There's another color balance that's going to bias it a little bit back toward where it should be. But then we're back at the red. So I then have to drop the red down. All right, and go through this again. So that's kind of where it belongs right there. Drop the blue one level. Okay. That's rough, but that's about where it belongs. Okay. So there you go. But that's cool. So we'll stop at this one. And we'll save it. Why not? I mean, I know there's streaks and everything, but yeah, that's fine. It'll remind me that we did Caldwell 7.
Sorry, that would be one to go back to. There's some fine detail going on in there.
Yeah, and once it's higher in the sky, it'll also be better. Because it's got to get higher in the sky for this to really be good. It has to come around the pole, basically. All right. So we're gonna take this down. Take this over here. Go to our 1 second view. Okay, and then we'll hyper it with our fake looking. There we go, with our fake looking stuff. That looks good. Okay, now. No, Isabella, I didn't say last one. Yeah, it looked a little better there, Curtis. But let's see. I know that I can. Okay, this will be pushing it, and it might not work, but I'm going to try it. Actually, I want to go east. I'm pushing my luck here, guys, but that's only because I'm trying to get us to maybe see something that is not yet ready to be seen.
M81?
Yeah.
Right.
Yeah, I mean, I might be able to see something. Let me get rid of this so I know the lines are there. My calculations will show us that the walls of the observatory will interfere, but once we have our lifting column under the telescope, it's going to be different. And go a little northward too. Yeah, we're going to go here.
You'll know. Ursa Major is well up, so you can see M81, M82 when Regulus is up in Leo.
Yeah. Okay, this is probably going to be the equivalent of like a 4-inch telescope because we've got so much of the main scope occluded by the wall, but let's see what we got. Yeah, it's definitely not going to work.
And actually, over here at least, Regulus is up right at midnight
Mm-hmm.
for the Leonids.
Yeah.
You might be a half hour later in Arizona.
Mm.
Sky time.
Yeah, right. Now, see, if I just wait another hour, then it'll probably be more doable. Well, let's just go see.
The Garland Galaxy. I don't remember that one.
What? Garland? Oh, that's Cigar Galaxy.
No, Garland.
Where are you looking? Oh, yeah, the Garland Galaxy. I see it now,
Sorry,
yeah.
I'm right down below Boday's Galaxy.
Yeah, I got you. Okay, we should be able to see something of this here. Yeah, but I gotta go wide frame here. Oh yeah, look at them. Got M81 and M82 in there. That's beauteous. Those are really pretty. But unfortunately, I think that we're gonna have a problem trying to see them. But we'll try it. Probably have to. Let's do a 20 seconds and come off here and then go into the live stack. Clear the stack if necessary. And it is. Yeah. Okay, here it comes. Let's see what we got. Yeah, okay. That's beautiful, though. I mean, we're going to have a gorgeous M81 view here. And there's the Garland Galaxy, by the way. Yeah. I told you guys in the past what that that red glow is. So to get back to that, with this red glow you're seeing here, there's a tiny red LED on the end of the camera, on the end of the telescope. And because our camera's off the front end of the telescope, it imparts a very, very subtle red glow to the building walls. And as you can see, that's what we're getting. Pretty cool, huh? Yeah.
Maybe you could get a piece of some electrical tape over it or something.
Well, as you can see, it's not much help. But you can see that M81 is definitely gonna. Oh, Vera, Lucia, thank you so much. That's so nice of you. Thank you. That's sweet. Well, unfortunately, when that was our limit, obviously, that's a limitation for us right now. So, and I was pushing that. Caldwell 7 was pushing it as well. So let's go back to something that we know we can see.
You know something you've never shown?
What's that?
I recall.
We did the
Polaris.
Mafia 1 group. Correct.
Polaris is a nice double star all by itself.
Yes, it is. It is. And although the telescope can do it, I'm not too excited about trying to make it do it. Now, we've seen this before. Okay, in H2 region, we're going to try this. Telescope's going to go hog wild right now. It's going to come back. Yeah, go the other way. Dang it. Get yourself going. This way, I'm unwinding all the cables that could be problematic. I just want to clear this first. And then come in here. Here we go. And get this and go to 1 second. Get that and go there. And hyper that. Hyper process. Oh, stacks on. I keep forgetting that. It's stacking. I don't want to do that. Gonna take that off and then it'll go right back to what we want. Alright, there we go. It's gonna center that up. And then go. Off we go. To NGC 7822, I believe. There it is. You can kind of see it there. Remember that?
Yes.
Okay. So let's wait here for the obligatory 8 seconds, 11 seconds rather, sorry, that we'll need, and we're gonna need, say, 20 seconds on this. Okay. And now let's go and do this. 20 seconds. Off you go. Live stack. Cleared last time, but we had some interfering stuff in there. Isabella, thank you. That's just wonderful.
You, Isabella.
That's beautiful. Thank you, Isabella. You guys are great. You are great.
They are.
Okay. There's the nebula. So let's work on a little bit of this. We're going to drop the red a little bit. Because there's other nebula here. And I think I need to go up a little bit. So we're going to clear this. And just go up a little bit. Okay. And this next photo will be kind of weird looking, I think. But it's alright. Yep. Kind of cool. Okay, now we clear this and And see, we got, and it's not the Caldwell thing now. It's not at all what that is. And I think it's NGC 7822. And there we go. There we are. Beautiful nebula right there.
Yeah, I remember that.
I think that's, I think I overstepped my bounds here. So I think the nebula is below me now. So what I'm going to do is I'm going to run back down to 1 second. But it's almost like no matter where you look, it's beautiful. You know?
Oh, yeah.
Yeah. All right. And let's do this. And do that. And then we'll see this little nebula over there. Or is that the nebula? What's that? No, I did that. I went south. Okay, so it is up higher. Oh, I get it now. Here's the nebula. Okay, so we're going to move the camera, telescope a little bit west. That should be good. Now we'll take the okay. Now we're gonna go in and just set the speed a little bit. Hold on just a minute. Okay. Now we can just set the speed. Okay. Now we'll go down a little bit here. Okay. And we're holding here. We're holding in a
Excuse me.
landing pattern. Okay, let's see now. It's going to go 20 seconds. 22 seconds, actually. Here. Good. Isabella is awesome.
You know, all our audience is awesome.
Yeah.
We wouldn't be anything without them.
I know it. Totally agree. Such good people watching us. Oh, I gotta clear this. I've been stacking all along. You guys are great. No doubt about it. Cypher 2, thanks for coming out, man, and really appreciate your help in the stream. It's beautiful. Thank you. Where the heck did it go? Did I go the wrong way?
There was that little red thing. Or is that another red thing?
Yeah, it's
No, that must be something else.
something else. I must be getting tired.
Yeah, me too. I'm yawning my head off.
Okay, so that's where we were going, and how do we get over there? Well, let's just reassign and realign and get it back there again. So we're gonna clear, kick, and go. Yeah, we're getting near the end, I'm sure.
The end of what?
The stream.
Oh. Yeah, I'm going to have to call it here pretty soon.
Oh,
I'm not falling out of my chair yet, but I'm yawning like crazy.
okay, well, no worries.
I mean, you can keep going if you want. I know how you are.
Yeah, but I will take it easy. Let's make sure that we're coming in on this thing and it's not a coordinate issue. Okay, good. Yeah, so that's where it is. I kind of see there's something there. So let's wait to 10 seconds or 11 seconds and let's do another 20-second shot here. All right, and then we'll go there. Get rid of our hyper processing, bring up our stack again. And here we go. So now our green process bar goes across. Isabella, if you want a telescope, we can help you find one. PG, thanks for coming by. Are you leaving? I didn't see if you were. There we go.
Cypher 2 said he was leaving.
Yeah. And PG might be going too, because PG said thanks, Daryl and Mark. So I think that's Petita.
Oh.
And let's go and drag this over a little bit. Yeah, see how that's looking? That's got too much red. Okay, we're gonna dunk some of the red. Okay. Dunk one blue. Okay. Oh. Well then, I think what Isabella is talking about is making her own remote telescope. That's what you're talking about is. Okay.
You know that I've told you about before. What's it called? Something Sierra out in California in the mountains there. It's a big astro village.
Oh yeah.
Some of their telescopes out there, they're you can hire the telescope, rent the telescope. What do you want to call it?
Well, you could do that in the Pecos Wilderness at Star Hill Inn. You can do that. There's each cabin location has a pad out back for a telescope that you can rent. You can rent up to like a 14-inch Celestron and do photography all week long if you want.
Yeah.
Wow. Here's a beautiful little stalk.
Yeah, we've talked about him before.
Yeah, we have. All right. Well, this has been a wonderful night, guys, and we've been checking out some really cool things. But I think we're going to call it quits right now. I don't know how many of these we stack, but I'll wait to get a number of these. Oh, we got 8. Okay. We're going to get to 10, then we're going to stop. As I said, you have the moon out. It's a lot harder. You got to definitely play with what we call flat frames. Okay. So that's going to be saved as a FITS file. And save it exactly as seen. And let's just get out and take a look at it. There we go. Maybe. this and move it over a little more. Wow, look at this is beautiful. This red one shows up very nicely.
Got more streaks showing up in there too.
Yes, I see that. Yeah. That might be a dithering issue too, actually, but we'll see. Oh, David Schmidt, you saw a video about making an 8-inch Plutonian. Okay. Copy down David's post there, guys. And then just disassemble it and make a YouTube address out of it. How come David Schmidt is not... okay, hold on, David. Okay, David, now you can post the links. You can post links now, David. You have a wrench. Okay. All right. Well, here's what we're gonna do. Did I save this already? I cannot remember. Doesn't matter. I can have two. So, we'll see what happens over the next couple days. I like trying to image stuff at the full moon because it really tests the equipment. They never look good, but it tests the equipment. Okay, so that said, okay, the first thing we do is we get out of this mode so we can see the screen and see everything going in there. Okay, subscribe and enjoy SkyTour LiveStream. Come along with us. We're also starting a new program where people can, for a nominal fee, they can, have us privately one-on-one and go around the sky to look at things that they want to see, or have a personal one-on-one, so that it's not just through a chat. You can talk directly to us and be in touch directly with me or Daryl or whoever's in the stream.
You are?
Well, I'm doing it, but if you want to join, you can.
I know.
I mean, because people want to see stuff, and they don't necessarily want to see everything that we want to see, so they kind of sit through it. But this way, the night is yours, and if you don't know what you want to see, we'll give you suggestions, and we'll take you to some things. But it'll be if Daryl doesn't join, it'll just be you and me, and that's something that we'll probably build that out as an hourly thing. Or you can just join just come to these, which are always free. We'll do this. And if that's good enough for you, well, great. But if you want to actually get some footage, some data, we'll be happy to help you. I'd love to do that. Okay, I'm going to park the telescope, but I'm going to turn off the focuser, which is good. Our focus we used is 48,358. That's saved, so we're good there. Okay, and now we're gonna get rid of okay, that's gone. Interesting. All right. And
Mark, I'm dropping here.
yeah, you go ahead. Yeah, no problem.
Okay. everybody take care. It's been a great night. Wonderful seeing all of you. And until the next time, have a good night.
All right, Daryl, we'll see you later. We'll talk tomorrow.
All righty, goodbye.
Bye. All right, folks. Well, I hope you had a good time. I did. I'm glad that you joined us. Okay, telescope is parking. And telescope is now parked. You can tell because you can see the stars just drifting. The motors have been turned off. So I shut the telescope off. You see the turned off the pure power here. And now I will disconnect the camera. Camera's disconnected. Shut this down. And now we disconnect the telescope. And when it goes dark and all lights go off, it's disconnected, and then we can shut down. Yep. And now, just as a final bit of fun, I'm going to take the roof and I'm going to close it. And you can see that happen too, which is kind of fun. I hate this 1 second delay. It's maddening. Okay. Well, there's a telescope in there. You can see the camera on the end here. Actually, let's zoom in on that for just a minute. Just going to show you something. And then we're going to close it. Okay. There's a little light right on the end of this, that red light. And that red light is what you see hitting the metal rails of our roof system, which is kind of funny. And that's what we saw. Doesn't take much, especially with a very sensitive camera like this. Okay. Alright. Now I go into my observatory program here and I close the roof because we are shut down. And the roof go bye-bye. I don't know, for some reason, opening and closing a roof from 2,500 miles away just seems so cool. I don't know. Never mind using a whole scope. You know? Okay, we're going to close this down. Close this down. Close window. Now we're done there. Close all windows here. All right. So now we're done. And telescope is ready to go. Good night. And so are we. So you guys, I hope you had a good time. I know that I did. I know that I really enjoyed your company. Thank you so much. And we'll be back. We'll be back. The next potentially clear night. I gotta see what the moon's doing. All right, guys? So you have a good night, and we'll talk soon. See you later, everybody.